Right. So more than a revision, this is going to be more like a theory class for the center of gravity and simple harmonic motion. Right. Good morning, everyone. Good morning. Assalamu alaikum. Quickly drop a message in the chat box. In audience, shall we start? Right. So maybe schools here in a sector, that's a different story, but they will understand that last moment school will both කරන්න බැහැ කියන එක. They miss the revision, they miss the revision. Right? Now, center of gravity ඇත්තටම ගත්තොත් ඒක ගොඩක් නැහැ. But it will take a lot of time to discuss. I mean, there are a lot of things to draw. අන්තිම ගොඩක් දේවල් තියෙනවා. It takes some time to what do you call take the notes and but when it comes to the theory part, it's a very small theory part. Sometimes a bit other somewhere around 80 to 90% of center of gravity will run a proof of which you stay center of gravity okay, and then I'm starting simple harmonic motion. Right. So write the topic, take a new book. So since you are theory class students, you can continue with the theory books. Okay, no need to take a new book for revision. Right, take a theory book and put the date today. Put the date today and write the topic. Center of gravity. Center of gravity. Center of gravity. Okay. So we'll see in future if the participation of the students is not good now, we may have to change the time. Okay, we may have to change the time. Right. So today's session will be happening as planned. Right, the topic center of gravity. Now, when it comes to your syllabus, inside the gravitational field, especially we are discussing the Earth's gravitational field, right? Within the field that we are in and that we are discussing, we are not going to go above that. Okay. So when it comes to this lesson, remember that center of mass and the center of gravity is going to be the same. There are cases, there are instances where the center of mass is in a different place and the center of gravity is slightly away from that. Slightly away from that. ඒ වගේ situations උත් තියෙනවා naturally. But in your physics syllabus and in your combined maths applied mathematics syllabus, when it comes to the center of gravity, center of mass, where you find first of all we find the center of mass. And a center of mass we are calculating, we are considering the center of gravity also. Okay. So in your syllabus, center of gravity, center of mass, both are going to be in the same place. There are exceptional situations where the center of gravity and center of mass in two different places. When the full chances 3 and above. I mean, very rare. Okay. So whatever the examples we take or whatever the calculations we do is within the Earth's gravitational field. So it falls under the discussion where center of mass and center of gravity is in the same place. And the other thing, when it comes to my theory class students, right? We are currently in our theory class, we are doing integration, right? In our pure mathematics class, we are doing integration. And integration is almost done. But still, we haven't discussed the definite integrals idea with you guys. But in order to start the center of gravity, we need the idea of definite integrals. Aren't we going to understand this? No. Integration idea definite integrals understanding is easy. Okay. So as a prerequisite, we need to study about the definite integrals, right? So the center of gravity, we need to learn about the definite integrals, but these definite integrals are discussing integration also in pure mathematics. Okay, that's a different thing. But the parts that we need to understand, the basics of definite integrals, I'm starting to discuss that one first. After that, we'll be moving on to the center of gravity topic. And prerequisite definite integrals. Definite integrals. Liana, prerequisite definite integrals. From the previous lesson, this is what we need, right? Other than that, the one that we need in this center of gravity lesson is the taking moments. But when it comes to taking moments in this lesson, it's not going to be that difficult. There are difficulty in the right? Directly we can find the perpendicular distance from a selected point or selected axis. Take a picture amount right? Definite integrals. Now we know that when it comes to differentiation or else first derivative of a function gives us the gradient at a gradient of a generally selected point, right? Generally selected or general point, generally selected point. සාධාරණ ලක්ෂණදී තෝරාගත් සාධාරණ ලක්ෂණ that is ස්පර්ශ කියනවා. What is it? Gradient of the tangent, okay? Gradient of the tangent, okay? At the gradient of the tangent at the generally selected point. For example, let's say we have y equals to fx function. This function's graph is this, like this. I'm selecting this point. So let's say the general points, I will make the general coordinates as x comma y. If I draw a tangent at this point, okay, this tangent's gradient, let's name the gradient as m, given by dy by dx, which is f dash x. So first derivative of a function gives you the gradient. The derivative of the function gives you the gradient at a generally selected point. First derivative the derivative of a function, because when it comes to practical instances like this, if you differentiate the, you see, S is the displacement. For an example, this is just an idea, center of gravity displacement, let's say t is time, right? When I differentiate the displacement by time, this gives you the gradient of the displacement time graph, which is the velocity, right? This gives you the velocity. And if you differentiate the velocity again with respect to the time, this gives you the acceleration. This gives you the acceleration. So this is basically, if I take this one as, if I take this one as y, okay, this is dy, this is going to be dy by dx, where d squared by over dt squared, right? Second derivative, right? Second derivative. Second derivative with the acceleration, but second derivative is actually the gradient of the velocity time graph. Velocity time graph a gradient, right? So instead of saying directly the first derivative of a function, derivative of a function is actually giving you the gradient at a generally selected, the gradient of the tangent at a generally selected point. That is derivative, differentiation. So what happens in integration? Okay, what happens in integration? Integration or as integral of a function gives you the area under the curve. Area under the curve. Okay. Further discussions gives you the volume. Again, when it comes to integration, it primarily gives you the area under the curve. Integration එක තව කරගෙන යද්දී. Okay, when we do more calculations using integration, when the පොඩ්ඩක් deep යද්දී, in integration we are getting a volume of a solid. Okay, volume of something. Integration primarily gives you the area under the curve. තව පොඩ්ඩක් කතා කරද්දී it gives you the volume. It gives you the volume. So other in center of gravity අපි මෙතනට වෙනකන් යනවා. Actually, not directly. In our pure mathematics class tonight, we'll be discussing the definite integrals. Correct? Definite integrals කතා කරලා, if time permits, we'll be doing the volume part also. Right? So that's the practical application. You will get a short question from this directly. So integration idea is basically the area under the curve. So we can get the volume. So we are going to discuss about how to get the volume, right? In one way, in under the center of gravity part. Right? So in integration, if you want to calculate the area value, we need to identify the limits properly. And a limits can put them up. උදා අපිට එන්නේ definite integrals idea. Right. So for an example, let's say we have I equals to integral x to the power 2 dx. What's the integration of this? I equals to integral x to the power 2 dx. This is x to the power n form. Function to the power n form, or as variable to the power n form. What's the integration? Variable to the power index plus 1, 2 plus 1 is 3 divided by 3, no? Plus c. C is an arbitrary constant. But if I give you the same question like this, we know these are x values, which means on x, this is x square means it's a graph, no? So if I plot the graph, let's say this is x-axis, y-axis, there is a minimum graph touching the x-axis at 0. Right? It's a symmetric distribution. So x goes from minus side to the plus side. Name it. Right. So let's say if I integrate this, it gives you the area under the curve. So if I want to calculate the area, let's say I need to calculate the area when the graph x goes from 0 to 3. 0 to 3 at the under the curve, this is the area I need to calculate. I want to calculate this area. Then x is going from 0 to 3, no? So I equals to integral x is going from 0 to 3. 0 to 3. The lower limit, again, left to right usually this can change depending on the context, right? This can change. So complicated instances or those kind of instances in integration. Okay, so just to give you the idea, x to the power 2 dx. Now this is a definite integral. Not definite integral. So I equals to x square. When you integrate it, you get x to the power 3 divided by 3. In indefinite integrals, we put an arbitrary constant. In definite integrals, we don't put because we know precisely what we are going to get. So we put a bracket like this. Lower limit here, upper limit here. Lower limit here, upper limit here. Now listen. How do we simplify this? Remember, when there are constants like this, I can take the constants outside. So 1 over 3. So we have x to the power 3, 0 to 3. simplify I equals to study with a very calm mind. කලබල වෙන්නේ නැතුව ඉගෙන ගන්න. කලබල වුණොත් මොකුත් කරන්න බෑ. Understand that the exam is close. You have to have the exam here by now. Exam එක by then දෙන්න ඕන. That doesn't mean you have to panic. Panic වුණොත් මොකුත් කරන්න බෑ. හොඳට අහන්න. X to the power 3 to the power 3. Right? So how do we simplify this? Open a bracket. Substitute the upper limit in the variable. Upper limit is 3, 3 to the power 3. Minus, always minus, substitute the lower limit in the variable 0 to the power 3. So this gives you 1 over 3 times 3 to the power 3 is 3 times 3 is 9, 9 times 3 is 27. Divide by 3, you will get 9. So you get I equals to 9. What is it? Square. I just write like this, units square. Units square. Again, මුගේ area එක 9 square units. If the units given in meters, it's going to be square meters. Unknown area. Right? If we rotate this one 360 degrees, we get a solid. එතකොට ඔක pi වලින් වැඩි කරලා මේ pi 5 sorry pi function square එක integrate කරලා අපිට volume එක ගන්නත් පුළුවන්. We'll talk about that one later. ඒවා පස්සේ කතා කරමු. ඒවා ලස්සන දේවල්. එකපාර කතා කරන්න බෑ. Okay? So what is definite integrals? Be precise to calculate the value under the curve. So this is a simple example that I can give you. So this idea is enough to understand the center of gravity idea. Right. The prerequisite write down this one. And if you all understood that one, drop a message in chat box quickly. Quickly, yeah. So මෙතන school ගිය set එකක් ඉන්නවා now. කවුද නැත්තේ? Quickly write this down. ඉක්මන ලියා ගන්න. Understand and work. Understand and work. Understand and work. My audio clear, right? Audio එක ඇහෙනව නේද? Right. I think the audio was low. කලින් කතා කරද්දි හොඳ වෙලාවට මේ environment එකේ sound එකක් තිබ්බේ නැත්නම් I was audible to you. I think audio is better now, right? I changed it to the mic. Now only I noticed that. Audio is okay, right? Okay, right. So I'll give you 2 to 3 examples. ඊට පස්සේ අපිට යන්න පුළුවන් center of gravity වලට. Quickly write this down. If you all are done with this, done කියලා දාන්නටක් ගාලා. If you all have completed this, quickly put done. Just a small opinion from you guys. Then join වෙලා ඉන්න කට්ටියකින් නිකන් අහන්නේ. Okay, right. We'll do an example, 2-3 examples. Make කරන්නකො. Quickly, I equals to integral 0 to pi sine theta d theta. I equals to minus 2 to plus 1 2x over x squared plus 1 dx. I equals to integral minus pi to plus pi sine theta cos theta d theta. Do these three questions. Do these three questions. I told you, no, integration kila kiyanne definite integrals is only thing. Once you after getting the integral, you have to do some further simplifications. You don't put the arbitrary constant. That's the only thing. So we do these calculations just to give you an idea. In order to start the center of gravity, we need this idea. Okay. Right. How is it goes? I'll take the first one. I equals to integral 0 to pi sine theta d theta. We know sine theta integral is minus cos theta, no? Minus cos theta. What's the limit? 0 to pi. So I equals to these constants you can take outside minus. Now cos theta, a variable substitute with the upper limit cos pi minus cos 0. So I equals to cos 180 is equals to minus 1. So we get minus 1 minus cos 0 is equals to 1. Cos 180 minus 1, no? Yeah. So I equals to minus 1 is equals to minus 2. Minus into minus equals to plus 2. So I equals to 2. Do we have to write at square units? Idea okay. I wrote this one just to give you an idea. Okay. Second one and third one. Right. Next one. Second one, I equals to integral minus 2 to plus 1 2x over x square plus 1 dx. So you can see that denominator's first derivative is in the numerator. Denominator's first derivative in the numerator here. X square plus 1 when you differentiate it here. X squared plus 1 when you differentiate it. X square first derivative is 2x plus 0 which is 2x. Then, so the denominator's first derivative in the numerator means we can go with ln form. Ln modulus x square plus 1. We have the definite integral minus 2 to plus 1. Right. So I equals to ln 1 squared minus 2. 1 squared minus 2 minus ln minus 2 squared. Sir, minus 2 name. Sorry, my bad. Plus 1. 1 squared plus 1 minus ln minus 2 squared plus 1. So this gives you I equals to ln 1 squared is 1, 1 plus 1 is 2, ln 2 minus 2 squared is 4, 4 plus 1 is 5, ln 5. So we know that in log, according to log rules, we can take it as 2 over 5. Or normally under proof. Okay. Substitute the upper limit in the function minus substitute the lower limit in the function. Substitute the upper limit in the function minus substitute the lower limit in the function. That's it. උඩ එකව substitute කරා minus යට එකව substitute කරා. That's it. Right.
Third one, I equals to integral minus pi to plus pi sine theta times cos theta d theta. So we can see if I multiply and divide by 2 here, see minus pi to plus pi 2 over 2 sine theta cos theta d theta. I'll take this half outside, 1 over 2 integral minus pi to plus pi 2 times sine theta cos theta sine 2 theta d theta. Sine 2 theta integral is minus cos 2 theta divided by 2. 1 over 2 is equals to 1 over 2 multiply I equals to 1 over 2 multiplied by cos 2 theta divided by 2 minus pi to plus pi. Samahara Kattiya, some people, some lecturers write like this also. Mehemat line minissu inno. Awulak ne. No problem with that, okay? But I recommend you all to go with the brackets like this. So now I equals to half. I'll take this half outside. This becomes 1 over 4 cos 2 pi minus cos minus 2 pi. Substituting pi here, cos 2 pi minus cos 2 times minus pi minus 2 pi. Cos 2 pi minus cos minus 2 pi is again cos 2 pi. What is 2 pi? Cos 360. What is cos 360 value? Mataka නැත්නම් බලන්න මේ theta or as x. When the angle is 0, cos value is 1. 90, cos value is 0. 180, cos value is minus 1. 270, 0, 360, plus 1. You should remember those values, right? So 360 is plus 1. This is plus 1 minus 1. You see, I equals to 1 over 4 plus 1 minus 1. 0, no, here minus cos minus 2 pi is cos 2 pi only. Again, this one is plus 1 minus 1. 1 minus 1 is 0. 1 over 4 minus 0. 1 over 4 multiplied by 0 is 0. So no area under that curve. Again, හරියට නිකන් මෙන්න මේ වගේනේ පුතා. It's correct, no? X, Y, right? So let's say make a 2x, this 2 theta angle only, I'm taking it as x. Sine 2 theta means, which is something like sine, defined sine curve. This is a defined sine curve. Komahari, the defined sine curve goes like this, no? Haranekang 0 to pi, pi to 2 pi. There is a plus area, there is a minus area, cancelling out 0. Total area, sapala varga pale, the effective area is 0. Harane? Effective area is 0. Sine 2 pi 2 theta, when we are taking the angle for, actually this is not the one we are taking. Minus pi to plus pi අපි ගන්න මෙහෙම ගත්තොත් here x එහෙම නැත්නම් I'll take this as 2 theta angle. Define sine curve එකක් නෙන්නේ. So minus 2 pi to plus minus pi to plus pi. You see? Minus pi to plus pi. කොහොමද තියෙන්නේ? So minus area plus area, again cancelling out 0 because these are identical parts. Again, integration කියන්නේ පට්ටම ආතල් ඒරියා එකක් හරි. Actually maths කියන්නේ ආතල්නේ බං. උඹලා තේරුම් අරන් කරේ නැත්තම් තේරුම් අරන් කරා නම් කරේ නැත්තම් ඉතින් ඔක ආතල් එක තේරෙන්නේ නැහැ නේ. Right? Maths කියන්නේ හෙනම ආතල්. Now when it comes to have you ever thought කොහොමද මේ GPS calculations වෙන්නේ? Relative velocity, relative acceleration. But වැඩේ කියන්නේ most of the things that we do in A-level limit is actually having errors. Errors තියෙනේව කරන්නේ හරි. Now in center of gravity, when we study the center of gravity, you will understand that we do lots of assumptions. අපි දෝෂ සහිත ගණනය කිරීම කරන්නේ. We are doing calculations with errors. in university level, if you all are going to engineering or if you all are doing something in relation to mathematics, further mathematics further mathematics subject numerical analysis, linear algebra, calculus, again in A subjects karaddi, you will study how to eliminate these errors. Right? A product company when we manufacture a product and when we put that to the market, the value of the product is changing depends on the quality. Quality up when errors aduwenna ona. Errors aduwenna nan ekata ona calculations karanna ona. Right? So the mic that I'm using at the moment is one of the Honda company mic, but at the lowest cost. Right? The mic that I have in other hand, company. The price range, the audio, you feel like the same kind of audio is coming. No, if I'm using the other mic, you will hear my voice same as this, right? But the price range difference is somewhere around with the current market 40,000 to 50,000 difference in a mic, right? Make a 14,000 or 80,000, 60,000 or something, right? Mics wala price range venas wenima kohomada depending on what, maybe the long lasting quality. A long lasting quality එක හදන්නෙක් maths calculations ඕනේ, because long lasting means the electronical equipments or electronical tools that has been used inside the chip or the circuit is having a higher accuracy and a lower very small deficiency. Or is no almost no errors lagi, no errors hadanna bෑ, zero errors equipments kawadaවත් hadanna bෑ. Right? We can't manufacture anything in this world without an error. අනිවාර්යෙන් fault එකක් තියෙනවා, but that error significantly we should reduce. හරි? එතකොට මෙතන කතා කරන්නේ in center of gravity we are not going to study about how to reduce those errors. ඔන්න අනම් මනම් මගුල් මුකුත් කතා කරන්නේ. We are going with a lot of assumptions and do. Right? So we wrote the topic center of gravity and we wrote something called prerequisite and we did the integration needed part for this session for the center of gravity part. Now write the topic as a subtopic again, center of gravity kila alien. Write again center of gravity. Center of gravity. Definite integers මෙච්චරක් නෙවෙයි ඈ, තව ගොඩක් තියෙනවා කරන්න, but for the center of gravity this is enough. So we will discuss about in integration class, we will discuss about the definite integrals in deep and further heavy calculations with the past papers, model papers. Right? So the center of gravity, today we will be finishing somewhere around 70 to 80% of the theory. Labana Sati center of gravity. So in your applied mathematics paper, relative velocity question, you will see vectors and system of coplanar forces. You will see, okay, vector system of coplanar forces, equilibrium and jointed rods, relative velocity question එකක්, center of gravity question එකක් තියෙනවා ඔයාලගේ applied paper එකේ. And when it comes to pure paper, integration ඉවර වෙලා I'll be doing binomial theorem and then mathematical induction. In pure paper, you will get mathematical induction, binomial theorem and integration. Again, pure paper 5 essay questions complete, right? Circles last part podi kalla katha karanna dina this Thursday night we'll be finishing, day after tomorrow ඒක ඉවර කරලා දාමු පුතා. ඇද ඉන්න බෑ, මට අරගන්න බෑ. Last week I was supposed to do but couldn't do with the situation, අර country එකේ තිබ්බ situation එකකින් ඔහොම ඇවිල්ලා වැඩ ගොඩ ගහලා පට්ට කෙලවෙලා තිබ්බේ plans ටික සේරම. දැන් තමයි සේරම streamline කරලා තියන්නේ ආයි. Right? We had to even postpone the statistics seminar to January, right? So then සේරම streamline කරලා තියන්නේ. දැන් හරියට plan ටික හරි. So this Thursday we'll be finishing off circles. So if you finish off circles, quadratics plus polynomials 1 essay question, trigonometry 1 essay question, differentiation 1 essay question, integration 1 essay question, and then straight lines and circles, one essay question. So එතකොට තව essay questions දෙකකට අපි වැඩ කරන්න තියෙනවා. Those two essay questions are coming from matrices plus complex numbers එකක්, permutation and combination plus series එකක්. Right? So එතකොට 1 2 3 4 lessons are there to study in relation to the essay paper. Right? Short questions paper එකට කතා කරන්න තියෙනවා අපිට binomial theorem and mathematical induction. මේ දෙක මේ මාසේ ඉවර වෙනවා. So January probably I'll be finishing these two, permutation and series. Feb වෙද්දි මේ දෙකත් ඉවර වෙලා තියෙයි. හරි? So pure maths එක එතකොට you can complete the 100% pure paper. Applied paper එකේ statistics January ඉවරයි. Center of gravity and SHM this month ඉවරයි. Relative acceleration, relative velocity ඔය parts ටික තියෙනවා, and impulse and collision එක කරා නම් applied maths එකත් done. Okay, so Newton's laws part එක I'll be doing along with I'll be doing that one after the relative acceleration කරාට පස්සේ I'll be doing that part. හරි? Okay, දැන් අහන් ඉන්න. Center of gravity. In Sinhala we say that Gurutva Kendraya. Why I am giving you the Sinhala terms? Sinhala medium එක හොඳ ප්‍රශ්න තියෙනවා ගන්න. Right. ලියන්න center of gravity. Now write a note like this. Quickly write a note like this. In this lesson, we learn how to calculate the in this lesson we learn how to calculate the in this lesson we learn how to calculate the in this lesson we learn how to calculate the in this lesson we learn how to calculate the center of gravity. I mean, how to calculate the position of the center of gravity. I mean, how to calculate the point of action of the center of gravity. The position of the center of gravity is better. Okay, in this lesson we learn how to calculate the position of the center of gravity, position of the center of gravity of symmetric objects inside the bracket, right? Matters, symmetric objects or symmetric matters, samamitika padartha, symmetric objects or symmetric matters, samamitika vastu ho samamitika padartha. The symmetric objects inside the bracket, symmetric matters. Right. Before we discuss about the symmetric objects or symmetric matters, now stop work here, listen. Discussion එක මාරාතල්. I'm taking an object like this. ඔන්න will take an object. So this is a matter. Instead of the word object, we'll go with the word matter. This is a solid matter which has the mass capital M, not the weight. Okay, you know the difference between a mass and the weight. Mass capital M. The වැඩේ කියන්නේ, this is not a symmetric object, and we don't know where is the center of mass of this one or the center of gravity. So I hope in physics you have studied center of mass, center of gravity කතා කරලා ඇති. Right? කතා කරලා නැත්නම් physics අමාරු කරන්න. Right? Center of mass somewhere in this. Okay? So we don't know where it is, but I can do one thing like this. But මෙහෙම දෙයක් කරන්න පුළුවන්. මෙන්න මේ යකාව. I'm going to divide this capital M mass into tiny pieces like this, tiny chunks. ඔන්න පොඩි කෑලි වලට. Okay, චූටි කෑලි වලට. I'm dividing this one to small pieces like this, right? N number of pieces, some n number of pieces. So those are visible pieces that we can measure the weight, but n number of pieces. ගොඩකට කඩනවා, infinitely many n number of pieces. Visible n number of pieces. Okay, I'm dividing that one in small pieces. Each piece is having a mass. No, m1, I will take the masses as m1, m2, not equal pieces. Okay, different weights. කැමති විදිහකට කපනවා. m4, m5, m6. I'm taking the masses of them separately. M6, M7, M8, like that. It has different weights. So like that, if I'm dividing them into n number of pieces, there will be a piece. There will be a piece which has the mass Mn, right? Mn, right? I'm dividing into n number of pieces. Nth pieces mass, I'm naming it as Mn. Nth pieces mass. First pieces mass is M1. The second pieces mass is M2. I'm just giving a naming convention. I'm not taking the exact value of them because there is an algebraic representation. There is a general representation, just a normal discussion. We try to understand based on this one what's the what we can do. පොඩි සෙල්ලමක් දාලා බලනවා මොකක්ද අපිට කරන්න පුළුවන් කියලා. Right? Study properly. Don't write anything. Listen. So move chooty kadala. I'm dividing it in small pieces, and each piece is going to have a certain mass. So let's say I'm dividing this entire capital M mass, this entire capital M mass into n number of pieces. So I get the nth pieces mass as Mn. Nth pieces mass. So I'm going to take a representative of all these masses. මෙන්න මෙහෙම Mi. A representative of all these masses as Mi. ඔන්න මේක එක්ක අරගමුකෝ අපි. Representative of all these masses as Mi. So when I equals to 1, we get the mass of the first piece. I equals to its M2, mass of the second piece. When I equals to mass of the third piece. When I equals to 4, mass of the fourth piece. I equals to 5, mass of the fifth piece. I equals to n, mass of the nth piece. Mass of all the pieces, I'm taking a general piece like this. Right? කෑලි එක එකාට masses තියෙනවා. සාධාරණ කෑල්ලි. Right? උට කෑලි ගොඩක් තියෙනවා. All කෑලි represent කරන general කෑල්ල. That one's mass I'm taking it as Mi. Okay, I'm taking it as Mi. හරි. So එතකොට when I equals to 1 we get M1, when I equals to 2 we get M2, when I equals to 3 we get M3, and so on. So now one thing I can understand is that this capital M mass is actually a summation of the M1, M2, M3, M4, M5 until Mn. මුන් සෙට් එක එකතු කරොත් I get the masses of all these. Mass of all this. How about the weight? How about the weight? If I am taking this object, let's say this one's weight is capital Mg, if the gravitational acceleration in this direction, this is Mg. This has M1g, this has M2g, this has M3g, this has M4g, this one has Mng, this one has Mig, right? This is the weight or the gravitational force of the Mn or as nth piece. Nth piece. Nth piece's gravitational force or as the weight is Mng. This is the general weight that represents all of those weights. When I equals to 1, the first piece's weight. When I equals to the second piece's weight. So, practically taking, or is generally speaking, the weight is equals to M1G, M2G, M3G, M4G, plus and so on until MNG. MNG. The mehimalini karadarai. This is very disturbing to write. Hinama owl, hita upset matter. So what I'm going to do is, I'm going to write M. Put command. I'm giving a small command. What's the command? There are small pieces, each of them having some weight. Add all those weight, each of them having a mass. Add all those masses to get the main mass. Add all those masses to get the main mass. That's the idea. Or as the add all those small pieces masses together, then only we get the mass of the big one. Hurry. So add all of them. What's the command? Add all of them. Instead of writing like this, we can shorten it. We take the general piece. General piece's mass. When I equals to 1, we get the mass of 1. I equals to 2, we get the mass of 2. Mass of the second piece. When I equals to 3, we get the mass of the third piece. Set add all of them. Kina idea we put the notation sigma. Sigma means add karapang. Sigma means add karapang. Until when? Until I goes from 1 to n. When I equals to 1, m1 plus. This is like a nice operation, okay? What does it say? When I equals to 1, m1, sigma notation plus until I reaches n. When I equals to 2, m2, now the programming ICT karnunta mema danna athi. Right? The loops while loop, do while loop, you give a condition until the I satisfies this, something like that. Something similar to that. So when I equals to 1, m1, sigma notation plus I equals to 2, m2, sigma notation plus I equals to 3, m3, sigma notation plus until I get the value n, it will add all the things. So instead of writing like this, sigma notation. We put a sigma notation. This is a very simple thing. G is the gravitational acceleration. It's a constant. It's a constant for this globe, constant for this earth, not for the universe. This is a constant for this earth, no? Loke, assume that loke, when you can go to any Thoothukudi. Mona Dilli giyat, gravitational acceleration is 9.8. Right? Small changes are there. Right? The changes are there. But as a global constant, it's going to be 9.2. If I multiply both sides by G, we can multiply both sides by a constant. So we can write like this: mg is equals to G times sigma I goes from 1 to n mi. What is this? Just a basic idea of how to get the mass of an object by considering the general mass. So what's the ultimate idea? If we know the general mass of an object or general mass of a matter, then Based on that, we can create an idea to calculate the object's total mass. If we know the general mass of an object, we can create an idea to calculate the total mass. That's the learning. And we are going to do the future works. Quickly draw this, do this, drop a message in the chat box. Understood. Clear with that. I need individual responses. I need individual responses. Confident pita reply kaddapan balanna kollone killane. Sure, understood, clear with that. Right, do it. Right. Done neither. Okay. Then මෙන්න මෙහෙම අදහසක්. Right. Now a small idea like this. Thunder. I am drawing a fixed y-axis like this. Always remember, in center of gravity, we do the things by having a standard or else define point like this. Now only I understood. Board එකේ චූටි කේස් camera එකේ චූටි කේස් එකක් තියෙනවා. I didn't see that all this time. This is a perfect straight line හරි. හරියට 90 degrees වලින් මම ඇදලා තියෙන්නේ. But camera මෙතනට එද්දි පොඩ්ඩක් case. So if I want to make it straight for you, I have to draw angled. මේක කෙලින් ලයින් එකක් තියෙන්නේ හරි නැත්තම් බලයි සර්ට රූලක් තියලා කෙලින් ඉරක් අඳ ගන්න බැරිද කියලා නෑ මං ඇදලා තියෙන්නේ කෙලින් ඉරක් ඕකේ කැමරා එකේ ඉෂුව එකක් ළමයි ඉෂුව නෙමෙයි it's actually cropped and adjusted එහෙම කරලා තියෙන්නේ මේ සයිඩ් එක it's not showing straight it's a vertical line like it's a vertical straight line right so from this y axis distance to this m1 object m1 mass let's take it as x1 perpendicular distance මෙතන ඉඳන් to the m2 mass perpendicular distance is x3 m3 mass perpendicular distance is x2 make x3 and then m4 mass perpendicular distance is x4 like that for the mn mass perpendicular distance is xn and for the mi mass I'll draw that in green color for the mi mass the perpendicular distance from this y axis is xi okay xi for the capital M mass okay for the capital M original mass total mass the perpendicular distance from y axis is x bar I'll take it as x bar now I need to calculate the x bar distance I hope you all can see that I need to calculate the x bar distance what's our topic මොකක්ද අපේ topic එක calculating the position of the center of gravity of a symmetric object let's go before we go to the symmetric object we need to learn the concept now so I need to calculate the position of the symmetric object position of the center of gravity but when I give you the topic ඔයාලගේ ඔළුවට ගියාද කියලා or as you did you come across this question ද කියන එක you question it yourself මේක ආවේ නැහැ කියලා කියන්නේ උඹලා හොඳ ඉංජිනේරුවෝ නෙවෙයි if you did not come across the question like this like what තාම කිව්වේ නැහැ if you did not come across the question that I'm about to tell ඒ කියන්නේ ඔයාලා හොඳ ඉංජිනේරුවෝ නෙවෙයි I am planning to calculate the position of an object, the position of the center of gravity, position of the center of gravity, right? How am I supposed to find the position of something if I don't know a landmark? If there is nothing to compare the place with, which is something not moving, fixed position relative only we can tell another person's position no if someone is telling that Arman sir is here Arman Shaliki is in Bambalapitiya Bambalapitiya කියන එක කිව්වොත් දන්නවා the fixed place is Sri Lanka Bambalapitiya කොහෙද කියලා කියන්න නම් කොහොමද how people can say Bambalapitiya where Bambalapitiya LBS building third floor. So my position is explained or derived or pinpointed based on some fixed landmarks, fixed positions, fixed axes. Ehena, in order to tell where the hell is the center of gravity, we need to define a standard axis, a fixed axis, fixed y axis එකකට relative only we say fixed y axis එකකට relative usually we take the standard xy coordinates plane right relative to this one we know that what's the idea total mass is equals to the sum of all the other masses total weight is equals to sum of all the small pieces weights then the moment created by the weight mg multiplied by the perpendicular distance from the fixed y axis එක fixed තැනකින් තමයි හැමෝටම perpendicular distance otherwise our calculation is wrong From the one fixed axis only we have to calculate the perpendicular distances. Mg multiplied by x bar. So this is equals to simple m1g multiplied by its perpendicular distance x1. M2, I will write like this. Mg x bar, this is equals to m1g x1, m2g x2, m3g x3, m3g x3 plus so on, and mng xn, right? Sum of all of them. This one using the sigma notation, if we write mg x bar, before that here see g gravitational pull or as gravitational acceleration is a constant or as a common factor for both sides. Take g outside, g is cancelling out, so we get an equation mx bar is equals to m1 x1 m2 x2 plus m3 x3 and mn xn. So this mx bar I can write it as sigma I goes from 1 to n, m1 x1, m2 x2, m3 x3, mi xi. See? Pattern balala ganna puluwan wenna. mi xi. When I equals to 1, m1 x1 sigma plus. When I equals to m2 x2, sigma means plus. Add and add until you go to I equals to n. එතනට එනකම් ගන්න ඕන. Divide both sides by m, so you get x bar equals to sigma I goes from 1 to n mi xi divided by capital M. බලන්න scene එක. Step by step build up the staircase. If we have an object of mass capital M, theory ලස්සන්ට ඉගෙන ගන්න. Learn the theory properly. උස්සල පොළවේ ගැහුවා වගේ ගණන් හදන්න බෑ. So let's say this is an object or as a matter with mass capital M. I need to identify this bugger's center of gravity. මුගේ center of gravity එක මට හොයා ගන්න ඕන. To find the center of gravity of this one, number one, my thinking was, what if it is divided into small n number of pieces, which means all of them's mass summation is equals to this one's sum. ඒ හැම එකකගෙම sum එක සමානයි this one's total capital M. All those in small pieces weight, if I add them together, I get the weight of the total matter. Same as that, if I'm considering the moment around the y-axis, okay, if I'm considering the moment around y-axis in clockwise sense, I can see the moment created by the matter total mass should be equals to the sum of the moments created by the small pieces together. So from that we identified the location of the center. What is x bar? From this fixed y-axis, from the fixed position, from some fixed point, from some fixed known point only ne අපිට කියන්න පුළුවන්. මෙන්න මේ fixed known point එකේ ඉඳලා at an x bar distance we have the mass, center of mass or a center of gravity. At a fixed distance we have the center of mass and the center of gravity, right? This x bar distance is given by this one. By solving this we can get the x bar distance. Make a solve කරන්න. To get this sum අපිට සිද්ධ වෙනවා to use integration. We have to use integration. To use the integration, we need to first of all identify the general mass. If we know the general mass, I can create all these. Based on general and based on general mass, we can do all these calculations. To do the integration, I need the general mass. එහෙනම් පළවෙනි වැඩේ in center of gravity. Before we find the center of gravity, we need to learn how the hell we can calculate the general mass of a matter. General mass of a matter. So in your syllabus, there are certain set of selected symmetric matters given, and we are going to discuss only those things. ඒකෙන් එහාට syllabus එකේ අහන්නේ. Right? So we are going to discuss about selected set of matters. So what is the mi in this case? What is mi? General mass. What is xi? Perpendicular distance from fixed y-axis to the general mass. What is x bar? A perpendicular distance from the fixed axis, fixed y-axis to center of gravity. Center of gravity. Anna idea. Clear with that, fellas. Quickly drop a message in the chat box. Therunada adahasa. Understood. Loku scene ganna podiya tikina gam. Loku amaruවක් නෑ මේක. But still, if you haven't understood, let me know. We'll explain that part. I need individual responses. I need individual responses. Tagal liyaga. Finish it. Finish it. Arane, finish it quickly. Once you are done කියලා message එකක් දාන්න. And ළමයි, when you all are studying, learn with an excitement, okay? ඊළඟට මොකද වෙන්නේ? ඊළඟට මොකද වෙන්නේ? ඊළඟට මොකද වෙන්නේ කියලා හිත හිත කරන්න. Keep that curiosity. දැන් මෙහෙම ගියොත් මෙහෙම වුණොත් මොකක්ද වෙන්නේ? මෙහෙම වුණොත් මොකක්ද වෙන්නේ කියලා have a curiosity. එහෙම නැත්නම් උඹලට maths boring වෙනවා. මං හරි ආසයි උගන්නන්න. That's why I chose this profession also. Done. දැන් තියෙනවා පුතා වැඩ සෙට් එකක් කරන්න. Write the subtopic. Write the subtopic. Write the subtopic. Obtaining the general mass of a solid hemisphere. Obtaining the general mass of a solid hemisphere. Calculating the center of gravity එක පස්සේ කරමු අපි. ඉස්සෙල්ලා ලියන්න. Write the subtopic. Obtaining the general mass of a solid hemisphere. මෙන්න මේ mi වරගන්න එක තමයි ගේම. ඌව දන්නවනම් වැඩේ ලේසි. Right. Obtaining the general mass of a solid hemisphere. Solid hemisphere. Obtaining the general mass of a solid hemisphere. Right. මේක නිකන් මාර ආතල් වැඩක් හරි. අහන් ඉන්නකෝ. So I'm taking a, first of all, I'll draw a circle. Okay. Right. So I'm dividing this one. This is a solid sphere. So I'm dividing this one from exactly from the middle. So I get a solid hemisphere like this. The solid hemisphere. So let's name the center of this hemisphere, solid hemisphere, as capital O. Okay. And the radius as simple A. Radius as simple A. අහන් ඉන්න. දැන් මෙහෙම අදහසක්. If I want to calculate, get the general mass of an object or general mass of a matter, what was the idea? What was our initial idea? ඌව චූටි කැලි වලට කපනවා. Right? Dividing them into infinitely many pieces, but visible pieces. Visible infinitely many pieces. What? We are dividing them into small pieces. When it comes to symmetric objects, that division is going to be like this. We are going to split that into small pieces, but that division or the split should be all those small pieces having a same kind of a cross section. Area obviously the area is going to change, but the same kind of a cross section. Hitanno ඔයාලා දොඩම් ගෙඩියක් ගන්නවා. Now I don't have a දොඩම් ගෙඩියක් with me, okay? Now you have to imagine this. දොඩම් ගෙඩියක් ගන්න. Take a nice well sharp knife. නිකන් අර තිබ්බත් කැපෙනවා වගේ. Imagine it. We don't in any of our places we don't have that kind of knives, no, right? So අපේ ගෙවල් වල තියෙන knives කොහොමද? ඕක තියාගෙන මිනිස්සයාගේ බෙල්ල කපනවා වගේ ගාලා කපන්න වෙනවා, right? Obviously the knives we have at our place or at our home, only our mother can handle that knife, no, nobody else is like expert in that. අපිට පිහියෙන් කපනවා ඒ පිහිය අපිට කැපෙන්නේ නැහැ. අම්මට හොඳට කැපෙනවනේ, right? I don't know how many of you have seen that, right? So maybe we don't know how to handle the knives, or else she's an expert, or else some Batman wage some vigilante කෙනෙක්ද දන්නෙත් නැහැ. Right? So however, let's say you get a imaginary knife, okay, which is super sharp, patta tiyunu, right? Super sharp knife එකක් අරගෙන you split that දොඩම් ගෙඩිය orange into exactly 2 equal pieces, right? Let's say you got a nice bowl දොඩම් ගෙඩියක්, right? It's like a supiri lassana bowl දොඩම් ගෙඩියක්. You cut that into 2 pieces. Now එකක් විසික් කරන්න, එහෙම නැත්නම් කන්න දෙන්න මල්ලිට හෝ නංගිට, and take the other half. Now you have a solid hemisphere, no? Now you have a solid hemisphere. Then maybe මම පිහි අල්ලන් ඉන්නේ දැන්. Imagine, na? Now you have to imagine sir is having a dodang, half of dodang here, and knife is in his hands. දැන් මම ඔයාලට පෙන්නන්නේ මොකද්ද? කුණු හරප නෙවෙයි. What I'm showing to you? I'm showing the side view of the orange. Imagine. Then dodangidi kapala, I'm showing you the cross section of the orange. What do you see? You see a circular surface. No? Then මොකද්ද කරන්න යන්නේ? ඔන්න ආයේ පිහිය ගත්තා. Small slice. What do you get? Dodang petak. Right? Orange slice. You get an orange slice. What's the cross section shape? A circle. තියන්න පැත්තකින්. Again you cut. You get an orange slice. Right? Obviously, when you cut like that, you get orange slices with same cross section, not with the same cross section area, same shape of the cross section. Cross section shape is going to be the circle, 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 sambinne yanda chuti වෙනවා circle එක. Right? But you are cutting into infinitely many pieces. දැන් හිතන්න ඔන්න ඔයා කපනවා. Right? So you're going to cut like this. Since I'm using a whiteboard, I will use the ruler to cut. This is my knife. I'm cutting into small, small, small visible pieces. Onne kapua. I kapua. Okay, listen now, don't do anything. Small, small, small pieces. Each small pieces, right? How do we cut? Such way that all the pieces having a same cross section shape, same cross section shape එකක් තියෙන විදිහට කපන්නේ. ඔන්නෝම කපනවා. Right? ඔන්නෝම කපනවා. Right? ඔන්න කැපිල්ල. So same cross section, you are not going to cut like this, huh? You are not going to cut like this. මෙහෙම කැපුවොත් you are not going to get the each slice is not going to give you the same cross section. එකම cross section එක තියෙන විදිහ. එකම cross section එක ඇත්තටම තියෙනවා if it is a මේ හොඳ symmetric එකක් නම්. Alright? But this one is the correct one or the better one. එහෙම නැත්නම් calculations කරන්න පුළුවන් මේකෙන් විතරයි. Okay? So මෙන්න මෙහෙම cross section එකක් තියෙන විදිහ. So when you view from this end, you see the solid hemisphere is divided into small slices. Each slice is having a circular cross section. Area is different. ඔන්න ඔහොම slice set එකක් හම්බෙන්නේ. There are infinitely many slices. And each slice, now imagine you get such slice. You get such sliced orange piece. You get slice karapu, you get an orange piece. Imagine ඔයාට ඔන්න paper වගේ කැල්ලක් හම්බෙන්නේ. You are cutting them into small, infinitely many pieces and you catch one. Paper වගේ එකක් හම්බෙන්නේ. Circular orange slice like a paper. Right? ඔන්න ඔය කැල්ල, you have a very nice eye, you zoom it in. ඔන්න ඔහොම ගන්න කැල්ල zoom කරන්න. Zoom කර බලන්න යන්නේ දැන්. Now what we are going to do? We are going to zoom කර බලන්න යන්නේ. Listen, nah? Now, I can't take all of these people or all of these slices and do the calculation. So I need a representative of them. Same as the beginning. The big matter divided into small pieces. Each one of them having a different masses. To represent all of them, I am taking a general mass in mind, which is a general piece and general ith piece. General piece I. A wage, to represent all these slices, I need to select a general slice. මෙන්න මේ slice සේරම represent කරන general slice එක මොනවද? I need this general slice to represent all these slices. A selection of that general slice is the scene එක. අන්න ඒ general slice එක තෝරගන්න එක තමයි game එක. කොහොමද කරන්නේ? From the origin, එහෙම නැත්නම් from this center, usually we place the කොහොමද තියන්නේ? We place this object or as we place this matter on a Cartesian plane such that the center or as the origin is at the origin of the xy axis. ඔන්න ඔහොම තියෙනවා. We keep like this. ඔන්න ඔහොම තියෙනවා. Right? So to select the general slice, ගහන ගේම මේ. So to select the general slice, this is මේක අමුතු scene එකක් කරන්න යන්නේ. Listen, huh? Now, I'm thinking that general slice is like this. අහන් ඉන්න. So the selection of the general slice is පට්ට වැදගත්. More important. Listen. And it's very nice application also. What I do is to select the general slice, think that you have the complete. Now this is an imagination. What if I cut this one to infinitely many pieces having a similar cross section? This is the situation I get. Let's say you didn't cut. This is your imagination. You cut like this. You have the solid hemisphere. Still you have the solid hemisphere. Hitanda. Combined maths, applied maths කරනවා නම් imagination is very important. බලා අනම්මනම් මනෝ ගහන්න දන්නවනේ. Right? අවශ්‍ය නැති දේවල් සමහර දේවල් වල ගොඩක් දේවල් ලස්සනට කරනවා හිතේ. Right? දැන් මේකත් කරපන්. අහන් ඉන්න. Imagine that you slice this. So let's say now actually you have the complete solid hemisphere. Now I'm going to get the general slice representing all of them. So how do we get it? From the origin at a simple x distance. At a simple x distance, mama kapanawa. I cut from simple x distance. At a simple x distance, I cut. Are onno me kapuwa. And then after that, visible, no? Green color ka pena, right? And then after that, at a very small, I didn't get a slice, no? Imagine, meheme kapuwat mokakda inne. You get a bigger piece like this, and you get another smaller piece like this. That's not a slice. So I have to slice it. Slice karanna nang I need to take a small density, take a small thickness, no? Small thickness. I'm taking a small representative, small slice. Small. ඒකේ කියද්දි මතක් වෙන්න ඕන calculus. Small change, delta x, no? So at a small gap, at a small distance, delta x at a small distance, make a patta podi. Since we need to draw the diagram, I got a big one. But I could paint to draw the diagram to make your vision easy. Shoot gap delta x very small, patta podi. Ekak aragena, I'm going to slice like this. I'm going to cut like this. Cut like this. Now, this is the slice I have. This is the slice I have. Then we slice a gun delete. Now take this slice out. ඔන්න ස්ලයිස් එක මම එළියට ගන්නවා. ගලවලා එළියට ගන්නවා. හරි? What do we get? We get a slice like this. No? ඔන්න ඔහොම එකක්. Something like this. ලස්සනට අනිම චුට්ටක්. කැත. Right. We get a slice like this. What is the, now listen na. Then වැඩි පොඩි scene එකක් තේරෙන්න ඕන යාලට. You have to come across this doubt. That small slice, practically if you take, you won't see this curveness. You won't see this curvature. This curvature is not visible to your naked eye. That's why we zoom it in. Api zoom karla aran tiyenne. So actually, in reality, there's a small curvature. Because obviously, we are taking a slice. Metanin palhata yaddi, it's curved, no? Imagine this is a very small piece. Very small piece, very thin piece. If you put that into a microscope and zoom it in, you will see there's a small curve like this. There's a curve like this. The radius of the upper circle is not the radius of the bottom circle. The radius of the bottom one is different than the radius of the upper one. So, this delta x gap is actually through the center if I take the height is delta x. Through the center if I take the height is delta x. I'm going to draw a perpendicular straight line segment like this and a perpendicular straight line segment like this. We get a salmon tin cylinder එකක් නෙන්නේ. We get a cylinder like this. So what's the idea? This cylinder's volume is greater than this small slice's volume, no? Why is that? This cylinder has, when the slice cylinder has an additional part here. When additional part right? This cylinder has a greater volume than this one. That volume is ignored in calculations. Ignore because the volume increment or as the volume change of these two, disc or as this one, this small slice and this small cylinder. If this one's volume is, let's say, 500 cubic nanometers, 500, let's say 500 units, 500 cubic units. This one is going to be 500.000000000000001 unit. There is an increment, but that increment or that change or is that difference is not a significantly high difference. It's a very small difference. But where we can ignore. If you can remember, I told you one thing. We go with what? Assumptions. We go with errors. But error. It's an error. We ignore that volume change and consider this one as a cylinder. When volume change ignore karala, even though there's a curve, we consider this as a cylinder. We consider this as a cylinder. මේ curve එක අමතක කරලා actually this delta x height is through the center. Delta x height is through the center. මෙතනට යද්දි at this point actually the height is reducing, no? The height එක අඩු වෙනවා මෙතන මේ හරියදී. This delta x is not constant throughout the entire thing. යද්දි අඩු වෙනවා මේ පැත්තෙන් යද්දි අඩු වෙනවා. But this change is very small. So we ignore that one and consider this as a cylinder. We consider the perpendicular height as delta x itself. මෙන්න මේ this volume is ignored. ඒක ignore කරලා දානවා. Is ignored. So we consider this as a cylinder. If I want to calculate the area of a cylinder or a volume of a cylinder, may hangindako. Listen carefully, yeah. Listen very carefully. How to calculate the volume of a cylinder? Base area times perpendicular height, no? O level. If you take a cylinder, if the base radius is r, height is h, what's the volume of the cylinder? Pi. Base radius square times the perpendicular height. So I need the base radius or as the radius. Obviously the base's radius and the radius here different. Muge podi, muge lokui. Since we are ignoring this volume issue, we consider this as a cylinder, which means we are considering this radius and this radius don't have a significant change. Difference එකක් නැහැ කියලා හිතන්න. Actually this radius is bigger than this radius. But since the slice is very small, there's a small, very tiny change in the volume. Slice එක පොඩි හින්දා මුගේ radius එකයි කියලා හිතනවා. So I need to calculate the radius of this one. We know the radius of the hemisphere is A. So O to this point. O to this point. The length is A. Make a. Right? Radius to radius of the hemisphere. That is A. This is X. Then what is this? A squared minus x squared square root. Pythagoras. What is this? A squared minus x squared square root. Now make a square minus x squared square root. Square root. So I'm going to take the density of this one as rho. So I have seen different lecturers, different students, different people write this rho letter. It's a Greek letter in different ways. Mage O level kale mage lecturer rho එක ලිව්වේ මෙහෙම. He wrote the rho like this. ඔන්න ඔහොම. Okay. Some people write it like one as a P. එක මිනිස්සු එක විදිහට ලියනවා. Rho is this. Rho එක මෙහෙම එන්නේ. This is rho. ඔහොම ඇවිල්ලා ඔහොම ගිහිල්ලා ඔහොම. This is rho. හරියට ලියන්න. නැත්නම් ඔයාලට PQ rho R පැටලෙයි. ඉතින් හරියට rho එක ලියන්න. If you want, you can search the internet and see. What's the rho letter? This is rho. So I have seen some physics lecturers also. The pressure by a fluid calculate කරද්දී H rho G ලියනවා මෙහෙම. ඔය සමහර මිනිස්සු rho එක ලියනවා මෙහෙම. Looks like P. So it should be H rho G. කොහොමද? H rho G. ලස්සනට ලියන්න. If you are doing something, do it with a meaning. Right? ඉගෙන ගන්නදී හරියට ඉගෙන ගන්න. වැරදි කරන්න එපා. ඒක වැරදි නෑ. If you write the other notations, will they put wrong? අනේ නෑ පුතා ලකුණු දෙනවා. Why I'm saying? ඔයාලා එහෙම වරද්දලා ලිව්වොත් sometimes if the question have P row both letters there, ඔයාලා පටලව ගන්නවා. Because your handwriting when you are doing the calculation in the middle, you can't see what is your P, what is your row. දෙපැත්තම P එක row එක කපලා දායි ඔයාලා. Happens, huh? It happens. So letter එකේ variation එක තියාගන්න. Right. So I'm taking the density as rho. Now you have to have a question, why the hell is the density? What's the volume? First volume. O level science. Volume is sorry, volume name. What's the mass? What's the mass? Volume multiplied by the density. Mass of an object is equals to volume multiplied by the density. Volume multiplied by the density. Right? So I want to calculate the mass of this one. Let's say this is the general mass we are taking. I'll take it as mi. This one's mass is mi is equals to volume times the density. This is considered as a cylinder. Now how to calculate the volume of a cylinder? Radius square pi. Radius square. Radius is a square minus x square square root. If you square it, you get a squared minus x square times perpendicular height delta x times volume multiplied by the density. Density is rho. So we get mi is equals to pi a squared minus x squared rho delta x on general mass. Here pi is a constant, a is a constant, rho is a constant, x is the only variable. So when we apply the integration, this delta x becomes dx, right? Sigma notation becomes integral sign. අපි ඒක ගැන පස්සේ කතා කරමු. So this is how we calculate the general mass of a solid hemisphere. ඔක්කොම කිව්වා. කතා කරා. Right. Nicely draw this. Quickly do this. හිතලා කරන්න. Understood. All the possible aspects ටික explain කරලා ඉවරයි ඈ. Drop a message in the chat box. I need individual responses. Confident, understood. Okay, finish it. Quickly drop a message in chat box. Done. So, right. Done. Hari. Now listen, will you? So if we know the general mass, if we know the general what? If we know the general mass, we can calculate the total mass. කොහොමද? We know that total, if I take the mass of the solid hemisphere be capital M. If I take the mass of the solid hemisphere be capital M, what do we get? Capital M is equals to sigma mi, no? Sigma mi. I goes from what to what? I don't know how many pieces are there. We'll just keep like this because I goes from what to what we don't know. I goes from 1 to n, the y to 1 to 100th. We don't know. I just keep it as sigma mi. What is mi? Capital M is equals to sigma. What is mi? Pi a squared minus x squared rho delta x. Rho delta x. No problem. Now we can see pi is a constant, density is a constant throughout the entire object. No, density is not going to change. It's a symmetric solid object. So I'm going to take the constants outside. Pi and rho multiplication. So a value. So pi, rho, I'll take it outside. From a sigma notation, we can take the constants outside. So we get a squared minus x squared delta x. This one. Now here's the important idea. Capital M is equals to sigma delta x. We write that one as integration a square minus x square delta x become dx. But from where to where? That's why this axis helps us. This is 0, 0 point. This is a, 0 point. X goes from 0 to a. We are slicing like this. X goes from 0 to a. We are taking from x goes from 0 to a. This is the total mass. Or no total mass. Simplify. Capital M is equals to pi rho multiplied by pi rho multiplied by a square. There is an integration I can give separately. 0 to a square dx minus I don't have enough space to do that here. Minus 0 to a x squared dx. I'll put a complete bracket for this. Right, I'll do the below that one you do the simplification. I'll do the simplification here. I'll do the simplification here. Capital M is equals to pi rho inside the brackets. You see, A is a radius. Radius is a constant. Take A squared outside. A squared ke liye karna. I'll put a curly bracket. Okay. Take A squared outside. Okay. This is 1 dx. 1, if you integrate it, you'll get x. So x limit is 0 to A. Limit is 0 to, I'm integrating and then put the limit. That's it. Minus x squared, when you integrate it, you get x cube 0 to A. ඔහොම එකක් නෙන්නේ. X cube divided by 3. Sorry, I forgot to write 3. 0 to A. Simplify. Capital M is equals to pi rho. Simplify. A squared times upper limit minus the lower limit. X equals to A and A minus x equals to 0, 0. Minus, I'll keep the 103 outside. X cube, A cube minus 0 cube. M is equals to pi rho. A minus 0 is A cube. Okay. Pi rho A cube minus 0 cube is A cube over 3. On no homena. Okay. So this one is going to be 3, take a common denominator, 3A cube minus A cube is 2A cube divided by 3. So finally we get capital M is equals to 2 over 3 pi A cube rho on the total mass. They are to put their paint order. What's the volume of a solid hemisphere? O level. Volume of a solid hemisphere 2 over 3 pi radius cube, no? Solid sphere now 4 over 3 pi r cube. If it is a hemisphere, 2 over 3 pi radius cube. If I want to get the mass, volume multiplied by the density. If I want to get the volume again, divide this by the density. Then make a density can divide correctly. Mass divided by the density is volume. Mass divided by the density is equals to the volume. 2 over 3 pi radius cube. O level එක ඉගෙන ගන්න equation එක හැදෙන්නේ මෙහෙම. උඹලා එන කට්ටපාඩම් කරගෙන යනවා O level මෙහෙම આવොත් මෙහෙම කරනවා. හරි. දැන් O level එකකට ගිහිල්ලා වැඩ පෙන්නපන්. This is how we calculate the mass. Mass divided by the density gives you the volume. On the maths. Right? Then හිතලා බලන්න your O level U හිතලා බලන්නකො. ලැජ්ජාවේ බෑනේ. Volume of a sphere is 4 over 3 pi r cube. Volume of a hemisphere 2 over 3 pi r cube. Volume of a cone 1 over 3 pi r squared h. ගොම් පාට්නේ. ඒව හැදෙන විදිය මෙහි ඉගෙන ගන්න. How it came. Calculus. It came from calculus. Calculus වල idea එක ඉස්සෙල්ලාම ඇත්තටම කිව්වේ නිව්ටන්. මට මතක හැටියට නිව්ටන්. Right. වැඩේ ලස්සනයි. Finish it. Understood? Clear? Here I showed you how to calculate the mass only. The mass calculation එක විතරයි පෙන්නුවේ. I didn't show you the center of gravity calculation එක නෙවෙයි පෙන්නුවේ. How to get the mass, how to get the general mass, how to get using that, how to get the mass, total mass. That's it. Now calculating the center of gravity of this one එක වෙනම කතාවක්. ඒක අපි පස්සේ කතා කරමු හිමි. Done. Understood, completed. මොකෝ හිතෙන්නේ මේක ගැන? set නැද්ද ආතල් නැද්ද? මට නම් ආතල්. How about you guys? මට නම් මේක මාර ආතල්. උඹලාට set නැද්ද? ආතල් නැද්ද? එතන set ද ආතල්ද? drop a message in chat box. පොඩ active ඉඳපන් ඈ. Still 2 hours no? 3 වෙනකම් වෙලා තියෙනවා. තාම පැය දෙකයි ගිහිල්ලා තියෙන්නේ. Around 11, somewhere around 11, I'll give a break. Done, understood. Quickly, I need individual responses. Only one person responded. How about the others? Recording done. Write the subtopic. Obtaining the general mass of a hollow hemisphere. Obtaining the general mass of a hollow hemisphere. Hare. General mass of a hollow hemisphere. Okay. Ahangi. Right. Listen, nah. I'm not going to draw again. I'll just keep this figure. Listen. Same as the previous. What's the hollow hemisphere? Hari nikang. I don't know what kind of an impression this is going to be when I give this example, but that's the example that came to my mind. Puta කරන්න දෙයක් නැහැ. අනේ ඊට වඩා හොඳ example එකක් දැන් ආවා. කවන්නේ කලින් example එක හොඳයි. Right? You know අලි බෙට්ට. අලියගේ බෙට්ට දන්නවද? දන්නේ නැති කට්ටිය අත උස්සන්න. දන්න කට්ටිය අත උස්සන්න අලි බෙට්ට. අලියගේ බෙට්ට බං. Have you seen when an elephant eat this one, what do you call wood apple? Wood apple එක උ කාලා උ කඩලා අපි වගේ මේ ජූස් හදාගෙන බොන්නේ නෑනේ. Right? Elephant wood apple එක කාලා okay ඕක digest වෙලා ඊට පස්සේ උ බෙට්ට දාද්දි wood apple එක කැඩිලත් නෑ කට්ට එළියට එනවා. අක්ගාලා ඇරෙනවා. හරි. If you divide, if you split that and see inside that, you will see nothing. Wood apple එක කොහොම හරි උට digest වෙනවා. එළියට එද්දි කට්ට හැමම එනවා. Right? Full solid, I mean full complete wood apple කට්ට එක. අනේ හිතන්න ගන්න wood apple එකක්. Right? Hollow wood apple. Right? Now you are dividing that into exactly 2 halves. Exactly 2 halves. Taking 1 half, and now again we are going to slice it. Take a very sharp knife, slice it. Slice it. The circular surface to you. Circular surface or a circular face to you. So I'm slicing through the circular surface. Such way that I get slices. It has the same or it has the similar cross section. So in previous one we got filled circles. Now we get hollow circles like rings. We get rings. Rings එද්දි මෙන්න මෙහෙම කැපුවට ප්‍රශ්නයක් නැහැ. But the thing is we don't have matter inside it, no? We don't have matter inside it. So taking the height as this delta x is not suitable because no matter inside it. Hollow, no? Hollow. Empty. It's an empty. Hari nikang පොල් ටික ගාලා හරි අර තියෙන පොල් කට්ට වගේ. Right? Once the coconut ඔක්කොම අරගෙන half of a coconut shell අන්න ඒ වගේ එකක් තියෙනවා. Right? So there is nothing inside this, but you have a hollow hemisphere. So no matter inside it, so taking this one as the perpendicular height is not suitable. එහෙනම් මොකෝ කරන්නේ? Then I need to calculate this length, no? මෙන්න මෙයාව තමයි මට height එකට ගන්න වෙන්නේ. This is the one I have to take it as the height. Now we get rings. This is a curve. It's an arc length, no? From the side view, it's an arc length. How to calculate the arc length of a sector? What's the formula? You see, I'm taking here from this point to this point. I'll take the angle as theta, and this is a small change delta theta. Small change delta theta, and this one is going to be radius times angle delta theta on arc length. How did this come? O level. So O level මෙහෙම කියලා දුන්නනේ. O level we learned theta over 360 into 2 pi r. Yes, same formula only I used. What is theta? This is the sector we are taking, no? මෙන්න මේ sector. This is the sector we are taking. Angle at the center is delta theta. I'm taking radians. එහෙනම් මේක 2 pi. Radius is a. 2 pi and 2 pi cancelling out. A delta theta. Where angle is measured in radians. We are measuring in radians. Huh? We are measuring in radians. मैं radians वाली measure कर ला रहा हूँ. Angle is measured in radians. This is delta theta. So if I take this one outside, this is a hollow hemisphere. This is a hollow hemisphere. What is this? මෙයා කවුද? A delta theta. So this is a හරියටම බලු කරපටියක් වගේ. Right? This is a ring. Sonic ගේ ring එක වගේ කියලා හිතන්නකො. බලු කරපටියක් sonic ගේ ring එක මොන මගුලක් කර හිතන්නේ මේක ring එකක්. This is a ring. Right? This is a ring. This radius is not going to change here. A, this is x, this is a squared minus x squared square root of it. This is a ring. How to calculate? How am I supposed to calculate the volume of this? How to calculate the volume? We need the surface area, no, first. We need the surface area first. Again, Puta, this curvature is considered as a straight line. Same concept as previous. Volume change is very small, so we ignore the curve. We consider as a perpendicular height. So this is a what kind of a cylinder? This is a hollow cylinder. This is a hollow cylinder with a thin width. Choti width එකක් තියෙන, it's a hollow cylinder. Right? It's a hollow cylinder. අපොඩි case එකක් තියෙනවා. Sorry, I forgot to say one thing. This one is not going to be same a squared minus x squared, no, because there is no matter field in it. So taking the radius as a previous one is wrong. එහෙම කරන්න බෑ because no matter field in it. So what we do? මෙතන කපලා here same as the previous one, we slice at x, and again delta x distance we slice it. But the radius is going to be what? හිතන්න. Radius is going to be a sine theta plus delta theta. This is theta, delta theta. This is a. This is a sine theta plus delta theta. This is a hollow hemisphere. Hollow hemisphere එකක් තියෙද්දී we can't use the Pythagoras to calculate the radius because there is no matter inside it. So we have to go with this theta plus delta theta. Angle is theta plus delta theta. Hypotenuse is a. So the opposite side is a sine theta plus delta theta. That's the radius. But the thing is, delta theta means a very, very, very small angle. It's a very small angle. So we can ignore delta theta and we can write a sine theta කියලා ගන්න පුළුවන්. Delta theta is a very small angle. We can ignore that delta theta increment and we can take it as a sine theta. Now don't tell me, say delta theta is a small one, no? So can't we ignore this delta theta and just write a? අනේ ගොම්පාත් තර්ක ගේන්න එපා ළමයි. මෙන්න මේකනේ සීන් එක 7 plus 0.00001 is equals to 7.00001. Ignoring this zero set 0.00001 ignore karata, still this is almost equal to 7. But what if I multiply that one with this small value? 0.0000007. Multiplication එකේදී significant reduction එකක් වෙන්නේ. It's a significant reduction. No? Scale down. So multiplications, divisions වලදී small change no, we can ignore no. පිස්සු වැඩ කරන්න එපා. Addition, subtractions, no problem, because the small amount is reduced or small amount is increased. But in multiplication, it's not like that. In multiplication, it's not like that. You are maths people, I hope you all can understand that. Now, I need to calculate the area of this one first. So, area එක ගන්න ඕන. So, I will cut this. This is considered as a hollow cylinder. If I cut this, what should I get? This is a ring. This is a ring, right? If I cut this, what do I get? I get a sheet like this. I get a sheet like this, which has the height A delta theta. What is this length? What is this length? Circumference of this one, no? Circumference of this one, all of us. Circumference of this one. What is it? Circumference of this one is 2 pi radius. Radius is A sine theta. A sine theta. Now you have to understand that this is a solid. So the density was what? Volume density. What is this density? This is a linear density, actually a surface density. Varga ekaka ganatwe. This one Gana ekaka ganatwe. Cubic units density only. For the previous one, we used the cubic units density. For 1 cubic meter, what's the density? Here we cannot calculate for a cubic meter because we have a sheet. We can get an area. We don't have a we don't have a thickness. We don't have a thickness. Why we don't have a thickness? There is no matter. Thickness matter. So there is no matter, no thickness. So this is a very thin line. Very thin line. So there is no thickness. This A, if there is a thickness, then obviously we have to take the thickness, but there is no thickness. Right? There is no thickness. Practically, no thickness means we don't have a cubic unit. We have a square unit, an area. Here we have an area. So the density, remember what? Density per square unit. What is the density? Density per square unit means mass per square unit. Density means mass per cubic unit or mass per square unit, mass per linear unit. Mass for a length, a unit length. In some instances, we don't have an area, we don't have a thickness. Nikang thin wire ekak. This one's density is given kohamal. This one's density is given mass per length, mass per 1 unit length. For an example, if someone is saying 10 grams per centimeter, that's the density of this one. This is a linear density. In physics, you might have studied Rekhiya ganatwa in Sinhala. What does it mean? If I measure 1 centimeter, that 1 centimeter's mass is 10 grams. 2 centimeters, another 10 grams, 20 grams. Like that. So don't think that the density is always going to be in cubic units. Right? So this is a mass per square unit. Varga ekaka ganatwe. Okay, density per square unit, mass per square unit, density of a square unit. For 1 square unit, if it is in centimeter, for 1 square centimeter, what's the weight? What's the mass? For 1 square, 2 square centimeters, for another 1 square centimeters, what's the mass? Like that. That's the idea. Okay. Now listen. I'll erase this. Samanyan, when it comes to applied maths, usually lecturers don't discuss about those significant differences. Density කියලා දැම්ම ළමයිනොත් කිසිම අවුලක් නැහැ. නිකන් කරන විදිහට කටපාඩම් කරගෙන කරනවා. තේරුම් ගන්න නැහැ. In previous example, the density we used is a different type of a density. This is a different type of a density. That's density per cubic meter, cubic unit. This is a density per square unit. So there's another type of density. Density per, that's actually the linear density. Density per length. Okay, per unit length, density per unit length. එක තුන්වෙනි එක. That's the primary one. හරි. ඔව දැනන් තියාගන්න. Just tell me, haven't you studied this one in physics? Physics වල significant changes කියුවේ නැද්ද? So can you explain how did you get 2 pi sin theta, sir? 2 pi sin theta. Either O level B. O level B ni. O level B. Cylinder. This is a hollow cylinder. If you cut this one, you get a rectangle. The height is going to be the width. Circumference of the circle is going to be the length. If I take this radius as r, is going to be 2 pi r. Now the thing is 2 pi, radius is a sin theta. තේරුණා? දැක්කා? Did you see that? Sorry for what? මතක වෙන්න බෑ. Right. So I'm going to calculate the general mass of this one. Mi is equals to area multiplied by the density, mass per square unit, or as density per square unit. Area, how to calculate the area? Length into breadth. 2 pi a sin theta multiplied by a delta theta. 2 pi a sin theta multiplied by a delta theta. This is the area multiplied by the density rho. So this will give you mi is equals to 2 pi a square rho sin theta delta theta. That's the general mass. Okay. So if I am taking let the mass of hollow hemisphere be capital M. So we get capital M is equals to sigma mi. What is mi? M equals to sigma 2 pi a squared rho, 2 pi a squared rho sin theta delta theta. Take the constants outside. 2 pi a squared rho sigma sin theta delta theta. Now then theta goes from what to what? 0 to pi over 2, no? 0 to pi over 2. No sir, isn't it going to be minus pi over 2 plus pi over 2? We cut, no? Think මම මෙතන ඉඳන් at a theta angle we put a cut, at a delta theta angle we put a cut. ඔහොම හිතමුකෝ, right? X delta x ගන්න නැතුව, okay, you think like this. From here, at a theta angle, we put a cut. At another small delta theta angle, we put a cut. Remember, if it is a solid hemisphere, at a x distance and a delta x distance. If it is a hollow hemisphere, at a theta angle and delta theta angle. Meaning theta, capua, delta theta, capua. No need to measure from here. Measure enough to measure from here. So theta goes from 0 to pi over 2. So then I can write capital M is equals to 2 pi a squared rho times integration 0 to pi over 2 sine theta d theta. So M is equals to 2 pi a squared rho multiplied by plus under rho multiplied by sine theta. When we integrate it, we get minus cos theta, minus cos theta 0 to pi over 2. Simplify. Last simplify කරන්න. Simplify nicely. Simplify nicely. What do we get? Capital M 2 pi a squared rho multiplied by, keep the minus inside, minus එක ඇතුළෙම තියාගන්න ඕ චුට්ටක්. Cos pi over 2 minus cos 0. Cos pi over 2 is 0 minus cos 0 is 1 minus 1 minus 0 minus plus 1 වෙනවා. So we get 2 pi a squared rho. On mass එක. This is the mass. This is the mass of a hollow hemisphere. Mass of a hollow hemisphere. Okay. Mass of a hollow hemisphere. Alright. So this is what we get. If you multiply that with G, you'll get the weight of the hollow hemisphere. Right. Finish it. And write the topic. After that, write the topic. Obtaining the general mass of a. So this is the general mass. Oga general mass. Make a original mass or the total mass. General mass obtaining a topic. From that, we can do the further calculations. Right. Obtaining the general mass of a solid right circular cone. Obtaining the general mass of a solid right circular cone. Solid right circular cone. Don't memorize formulas. Memorize karan depa aaye to level wage. Process. You have to remember the process. Where to cut, where not to cut. How to cut. Kapana vidiha තේරුම් ගන්න. Calculating the obtaining the general mass of a solid cone. Solid right circular cone. Solid right circular cone. Solid right circular cone. Right. Okay. Done. Shall I erase the board? Shall I erase the board? Shall I erase the board? Guys. Quickly, shall I erase the board? Others, how about the others? Shall I erase the board? තාම ඉරි ගහනවද? Finish this and then write the subtotal obtaining the general mass of a solid right circular cone. ඊට පස්සේ hollow cone and then ඊට පස්සේ කතා කරන්න තියෙනවා a wire bended as a semicircle ඊට පස්සේ යන්න තියෙන්නේ to discuss about the derived figures. After that we have to discuss about the calculating the center of gravity calculation part with after that we'll have to discuss how to calculate the general mass of a compound figure and center of gravity of compound figures, whereas compound matters. So I ටික කතා කරා නම් center of gravity done. Right, I'm erasing the board. Obtain the mass of a solid right circular cone. Solid right circular cone. ඍජු වෘත සිලින්ඩරයක්. sorry ඍජු වෘත කේතුවක්. circular කියනකොට solid right cone කියලා දානවා circular කියන word එක එපා. Because when it comes to cylinders only we say it's solid right circular cylinder කියලා කියන්නේ for cylinders. For cones we don't say the circular word. මගේ වැරද්ද. Okay. All right. Oh, that's a different story. Somehow I was managed to do two figures with one. Now, Balan, I have a cone like this. Okay. මේක තව පොඩක් මෙහාට එන්න ඕනේ. Right. Now, tell me, let's say the height of this one is, or the slant height, the perpendicular height of this one is h. And I'll take the radius as a. Okay, I'll take the radius as a. Tell me, if I want to, I'll take the apex as capital O. If I want to slice this, කොහොමද කිව්වොත්, if I want to slice this one such way that all the slices having a similar circular, එහෙම නැත්නම් similar cross section. If I want to slice this one such way that each slice is having a similar cross section. එක වගේ cross section එකක් තියෙන විදිහට if I want to cut this, slice this, tell me, do I have to slice that one horizontally or vertically? I have to slice this one horizontally or vertically according to this figure. කොහොමද slice කරන්නේ? Horizontally or vertically? Problem message quickly. We have to cut. කොහොමද? එකෙක්ද answer කරන්නේ? අනිත් උන් කොහෙද? බුදිද? Horizontally or vertically? If I want to have a similar cross section. Vertically, right? If we cut horizontally, අපිට එන්නේ වෙන මගුලක් නේ. If you cut vertically, side එකෙන් බලන්න, you get circles. You get circles. Right? You get circles. Right. So I'm going to slice this. ඔන්න හෝ චූටි චූටි slices වලට කපන්න යනවා. Okay, like this. I'm cutting that into small slices. You nicely draw. පොඩි slices වලට කපනවා. Okay. Right. කැත ඉතින් කමන්න. Okay. So we slice like this. Then මොකෝ කරන්නේ? We need to get a general slice of all of them, no? The slice that represents all those slices. The slice that represents all those slices. Hari? So I'm going to place this one's edge here and the axis of symmetry on the x-axis. Axis of symmetry එක තමයි x-axis එකේ දාන්නේ. We put the axis of symmetry on the x-axis. We put the axis of symmetry on the x-axis like this. Now if I want to take the general slice or as the slice that represents all of them, මුන් set එකම represent කරන general slice එක ඕන්න. This is a solid. A solid ආවොත් මතක තියාගන්න through the x-axis only we measure. Hollow ආවොත් measure by the angle, okay? Measure by the angle. Now here see, but when it comes to cone, think කොහොමද කරන්නේ? So I'm going to cut at an x distance like this. ඔහොම කපනවා. Right? And again a small delta x distance. ඔන්න ඔහොම කපනවා. Okay? Now if we take this one and zoom it in, මම අරගෙන zoom කරොත්, I'm going to take this piece out. ඔන්න ඔහොම අරගෙන I'm going to zoom it. Okay? I'm going to zoom it. I'll place like this. A circular surface. These are not curves. These are straight lines, no? Because this is a cone, no? This is not a hemisphere. හරිනකම් බල්ලාගේ කෑම plate එක වගේ. But the thing is, බල්ලාගේ කෑම plate is hollow. This one is solid. Right? Now think how we are supposed to calculate this height. මූ හොයන්නේ කොහොමද? Right. First of all, draw this, will you? Quickly. ඉක්මන නදින්. Okay, right. දැන් බලමු ඔයාලට ගණන් මතකද කියලා. First of all, let's try to calculate this one's radius. Let's take, this is r, so I'm going to take that radius r. Let's see whether you all can remember O-level geometry. O-level කටපාඩම් geometry කරපු කට්ටිය නම් මතක නැතුව ඇති. Equiangular triangles. We have a triangle like this. Triangle like what? At an x distance. This is x. Okay. This is r. Okay. ඊට පස්සේ we have another triangle, the big one. I'll take the big one like this. This one is h, this one is a. 90 degrees. 90 degrees. Half vertical angle is same for both. Half vertical angle is same for both. දෙන්නම සමානයි. Half vertical angle is same for both. Then third angle is automatically equal. We know these two are equiangular triangles. In a pair of equiangular triangles, corresponding sides are proportional, which means r divided by a is equals to x divided by h. So if I take r is going to be ax over h. This is ax over h. See, radius එකත් විදිය. O level. A level නෙමෙයි මේ O level. Right? Okay. Now, මෙතනත් පුතා, if I extend this one a little bit like this, extend this one a little bit like this, and draw a perpendicular line, we get a cylinder, no? We get a cylinder. We get a solid cylinder. මෙන්න මේ වගේ එකක්. We get a solid cylinder. This is our original one. There's a small extra volume. Actually, our original object piece or as matter piece that we have with us is having a lesser volume than this. Lesser volume than this because this is the additional part. But that increment or that changes or that difference is very, 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 very small. Patta podi na අතහැරලා දාන්න. Ignore it. Our calculations are with errors, දෝෂ සහිත ගණනය කිරීම. The error handling part is not there in your syllabus. You will study that in further maths or in higher maths. Even in physics, when it comes to ideal gases, okay, physics in chemistry, when it comes to ideal gases, you have a formula PV equals to nRT. No? I think in chemistry, one step ගිහිල්ලා ඔයාට උගන්වනවා P plus මොකක්ද ඔන්න ඔහොම දාලා මේ හෙන්න ලොකු නෙවෙයි සාමාන්‍යයෙන් දිග සමීකරණයක් උගන්වනවානේ. They teach, right? The volume this one pressure adjustment and this one number of molecules adjustment. එහෙම එකක් උගන්වනවා. I don't know whether you have studied it, right? But actually the error handle කරපු equations හතරක් තියෙනවා for PV equals to nRT. Somewhere around 4. University level chemistry වල ඔයාලා ඉගෙන ගනි. Then how you know, sir? මම university chemistry කරේ නෑ. But when I was doing A levels, මම ගොඩක් දේවල් කියවලා ඉගෙන ගත්තා. ඒකනේ මට අමතක නැත්තේ. That's why I remember many things. උඹලගේ අවුල මොකද්ද? Recording and class එකේ කරන වැඩ ටික විතරක් කරන එක. ඒක නිසා ඔයාලට මතක හිටින්නේ නැහැ. You will have a very limited knowledge. You don't know the taste of having a vast knowledge. එකක් තියෙන එකේ taste එක ඔයාලා දන්නේ නැහැ. Right? සාමාන්‍යයෙන් හැම දෙයක් ගැනම යම් තරමක් දැනගෙන ඉන්න එක පට්ට ආතල්ල. Right? Maths උත් පුළුවන්, physics උත් පුළුවන්, chemistry උත් පුළුවන්. Right? කියන්නේ වෙනම line එකක්. ඒකත් maths උගන්නන එකට maths උත් පුළුවන් physics උත් පුළුවන් chemistry උත් පුළුවන් කියලා තව line එකක්. That doesn't mean I can't teach physics and chemistry. I can't teach physics and chemistry. ඒක උගන්නන්න නම් ඒ field එකේ qualifications තියෙන්න ඕන. I am well qualified in maths, not in teaching physics and chemistry. හරි. But මට මතකයි. You all have to have that memory. උඹලා මට වඩා බාලයිනේ. Right? You all are very younger than me. Compared to you, I'm old. So my brain is starting to expire. Ne? Right? එහෙමනේ. සාමාන්‍යයෙන් when the people are getting older and older, so people have very අමුතු misconception එකක් තියෙනවා. What is it? When you gain the experience, your knowledge is increasing. Knowledge එක එනවා. When you have experience, you understand many things, you get a greater knowledge. But අලුතින් හිතන්න බෑ. You can't think anything new. අලුත් products එනවා අඩුයි. Right? So for me, still I'm young era එකේ ඉන්න හින්දා මට තාම අලුත් ideas එයි. But in another 10 years, 15 years, මට අලුත් ideas ඉන්නේ. I won't get new ideas. ඒකයි companies වල young fresh graduates hire කරන්නේ. හරි? So young minds have a fresh brain. You generate new ideas, but lack of experience. ඒ හින්දා තමයි හොඳ mentor කෙනෙක් ගාවට යන්න කියන්නේ. So compared to me, you must have a good new thinking. එක තියෙන්න ඕන. මම ගණන් හදන්නේ I do calculations based on my experience. දැන් අවුරුදු 10ක් විතර maths නේ. Based on my experience, I do calculations. Based on my experience, I do the teaching. අලුත් thinking කියන එකක් ඔය compared to you, a brand new thinking කියන එකක් ඉන්නේ නෑ. Brand new thing. I'm not talking about it. I mean, තව අවුරුදු කිහිපයක් මට දැන්ටමත් අලුත් දේවල් ගොඩක් කරනවා. Compared to me, my lecturers might not have new thinking. අලුත් product එකක් to bring up with come up with a new business idea or new business strategy. And never ඉන්නේ. That's why businesses hire young people, fresh people, or with a 2-3 years or 5 years experience in තරුණ මොළ ගන්නවා. අවුරුදු 55 60 owners ලා 35 years 35 years 30 years graduates ලා with a 5 to 6 years experience hire කරන්නේ ඇයි? For the great for good positions. Their brains are fresh. They have some sort of experience, චූට experience එකක් හොඳ brain එකක්. Understand කරගන්න. So compared to me, you have a very nice brain, පුතා. Very fresh brain. When I was doing A levels, මට අපේ lecturer උත් මට එහෙම තමයි අපිට එහෙම තමයි. Right? It's actually the truth. So compared to you, your siblings have some different ideas, whether it's feasible or not. චූටි ළමයිගේ imagination එක බලන්න. See the small children's imagination. See their mind. Their thinking is completely different. Their thinking is completely different. They have they have a greater curiosity. They have very when it comes to learning, not academic or whatever, not academic in whatever the aspect. When it comes to the learning, they have a kind of a different view towards that. The ලංකාවෙන් මොකෝ කරන්නේ? පොඩි එකෙක් ප්‍රශ්න අහපු ගමන් මේ ඔය ගොම් ප්‍රශ්න අහන්න නැතුව නිකන් හිටපන්. ඔලු හැදෙන්නේ නැහැ. මේව හැදෙන්නේ නැහැ. So when it comes to O levels, අයනම මොකුත් බැරි විදිහට ළමෙක් කෙනෙක්. ඊට පස්සේ කියනවා my child is not good in maths. No. ඌට හිතන්න පුළුවන් කාලේ ඌට හිතන්න දුන්නේ නැහැ. Right? So when it comes to our days, අපේ කාලේ අපි මොන්ටිසෝරි යද්දි හරි 24 years back, 24 years නම් නෙවෙයි 22 years back වගේ. Right? එතකොට smartphones කියන concept එකක් නැහැ. Right? touch screen was there. Apple introduced Apple එතකොට touch screen ඇවිලත් නැහැ. We had the ගල් කටස් phone. ඇත්තම phone නෑ. Most of the places didn't have mobile phones. These 20 years, within these 2 decades only, technology එකේ improvement එක ආන rocket speed එකේ improvement එකක් තියෙනවා. Right? Social media නෑ. Basically the mobile phones නෑ. Computers were there, internet was there, but හැම ගෙදරකම computer එකක් තිබ්බේ නෑ. So Montessori's fans තිබ්බේ. And at ගෙදර ගියාම ළමයි සෙල්ලම් කරන්නේ with the area children or ගෙදර ඉන්න siblings ලත් එක්ක සෙල්ලම් කරේ නැත්නම් උට කරන්න දෙන්නේ උ නිදා ගන්නවා පොඩි එකා. අපේ කාලේ එහෙමයි. Why I am telling this? Now you all are sometimes maybe late because ඔයාලගේ වයස ගිහිල්ලානේ දැන්. තව පොඩි උන් ගෙදර ඉන්නව නම් උන්ට ෆෝන් දෙන්න එපා. Why? Age 3, age 4, age 5 ඒ age එක කියන්නේ you have to touch things and work, especially sand. මෙන්න මේ මෙතන තියෙන පුතා very sensitive nerves වගේක්. Now we don't have that sensitivity. එතන sensitive nerves වගේක් තියෙනවා. Those nerves directly send signals to brain. ඔක්කොම directly sending signals to brain, but make a creative thinking එකට help කරනවා. So පොඩි උන්ට sand, building blocks ඕ දුන්නම උන්ගේ ඔළුව හැදෙනවා. දැන් ඉන්න මොකෝ කරන්නේ? Even my cousin sister, okay? පොඩි එකට අවුරුදු 4යි. When she is getting bored, quickly දෙනවා මොකද අර කොකෝ මෙලන්ද? කොකෝ මෙලන්. කොකෝ මෙලන්ද, වෝටර් මෙලන්ද මොකක් හරි මගුලා ඕක දාලා දෙනවා. ඌ ඉතින් ඕක බලන් ඉන්නවා. Right? So when I go to their place, මට කනක් ඇහිලා ඉන්නේ නැහැ. Why? He always plays අර කොකෝ මෙලන් එකේ නැත්තම් හැම වෙලේම ප්ලේ කරන්නේ මොකද්ද? පොඩි එකා ෂක් ඩුඩු ගාගෙන ඉන්නවා. හරි. ඇති දෙයක් නෑ. ෂාක් ඩුඩු. ඔලු හැදෙන්නේ නෑ ළමයි. දැන් basically දැන් ඉන්න අම්මා තාත්තලා හදන්නේ අනාගත චූටි හරක් පැටව. වැරදි. Now you all have the time. Still your brains are not rotten. හිතන්න පුළුවන්. Unfortunately, you all are not used to it because English medium all tuition classes උඹලා මොල කාලා නන්නත්තර කරලා තියෙන්නේ. O level උගන්නනේ උන්ටත් qualifications නැහැනේ. උඩ පැනගෙන යනවා උඹලා. O level schooling ඉගෙන ගන්න. Study O level only from school. Right? ඒකට හොඳ ස්කෝල් එකකට යන්න පුළුවන් නම්. Because school lecturers means අදාළ ෆීල්ඩ් එකේ ඩිග්‍රී එකක් අරගෙන ටීචිං එක්සෑම් පාස් වෙලා එක්ස්පීරියන්ස් එක කියන ගුරුවරු. හරි? They know the lesson, they know the subject. එහෙනම් ISO school lecturers උගන්වන දෙයක් අපිට තේරෙන්නේ නැත්තේ. reason එක පුතා tuition කියන දේ අපි ලොකු කරගෙන. We prioritize tuition over school. Or we worship the tuition lecturers over the school lecturers. හරි? එතකොට මොකෝ වෙන්නේ? School lecturers ලා automatically comfort zone වැටෙනවා. බහුතරේ. They know that even though they teach or didn't teach, you are not going to listen. You are going to listen to the person who's teaching in the tuition class. ඒක යාලා දන්නවා. ඒකයි යාලා කරන්නේ නැත්නම් එයාලට එපා වෙනවනේ පුතා. They come with a very good preparation in the class. You are not concentrating or you are not cooperating to the lecturer means ඒ මිනිස්සුන්ට එපා වෙනවා. So batches 10ක් 15ක් ඒ මිනිස්සු එහෙම දැකලා එපා වෙද්දි අලුතෙන් එන batches වලට they are not going to support. It happened because of the tuition. ලංකාවේ මේ tuition අයින් කරන්න බෑ. හැබැයි අයින් කරනකම් ඉස්කෝලේ හැදෙන්නෙත් නෑ. හරි? මොනවා කරන්නද? මරුණේබා. Qualified lecturers are there in schools. Qualified lecturers are there physics ඉස්කෝලේ physics උගන්වන්නේ physics bachelors එකක් හරි masters එකක් හරි physics වල කරපු මිනිස්සෙක්. Right? English medium tuition classes වල physics උගන්වන්නේ කවුද? කොයි හරි medical faculty එක medicine කරපු මේ පොරක්. Right? දැකලා ඇතිනේ. මෙඩිසින් කරපු කොරක්. Engineering නම් කමක් නැහැ because engineering involves lots of physics. No physics විතරනේ engineering කියන්නේ. Engineering නම් ප්‍රශ්නයක් නැහැ. මෙඩිසින් කරපු මිනිස්සු physics උගන්වනවා. right ඊළඟට chemistry නොකරපු මිනිස්සු chemistry උගන්වනවා. දැන් මෙඩිසින් කරපු මනුස්සයෙක්ට chemistry උගන්වන එක ලොකු ප්‍රශ්නයක් නෙවෙයි. right most of the English medium classes. හරි O level එච්චරමයි medicine කරපු medicine undergrads teaching O level maths. People don't have a degree teaching O level maths. පන්තියේ වැඩක් දෙකක් පෙන්නලා පේපර් එකට ගාන හදන්න ඉගෙනනවම සර් පට්ට. උඹලා හැදින්නේ ඔය මයින්ඩ්සෙට් එක වෙනස් වෙනකන්. Okay. Right. Now again in this one පුතා when it comes to volume මගේ උන් please if you once you all are finishing this A level ඔළුව තියෙන reputation එකක් තියෙන හිතන්න පුළුවන් වැදගත් මිනිස්සු වෙලා ඵලයක් question paper එකට ගාන හදන එක නෙවෙයි මට ඕනේ ගානත් හදලා ඊට එහා හිතන්නත් පුළුවන් එකෙක් මට ඕනේ ඇත්තටම society needs them හරි you need you හිතන්න බැරි නම් පට්ට අමාරුයි life එක ගෙනියන්න if you take the volume of this the cylinder's volume is greater than this one's this original mass that we have or is original matter we have here matter slice we have here so but the thing is that difference in the volume is very insignificant it's a very small part so we can ignore it and take the perpendicular here this delta x as the perpendicular height directly when you calculate the volume so how to calculate the if I take the density here we have a solid one no Buddha so the density is going to be mass per cubic unit mass per cubic volume or is mass per unit volume mass per unit volume is this density mass per unit volume so I will take the general mass as mi how do you write the general mass Puta general mass is equals to volume multiplied this one has a volume no volume multiplied by the density what's the volume how to calculate the volume this is considered as a cylinder base area multiplied by the perpendicular what's the base area pi radius square radius is ax over h a squared x squared over h squared base radius square times perpendicular height delta x this is the volume multiplied by the density rho so mi is going to be I'll write it nicely pi rho a squared x squared over pi a squared rho over h squared times x squared delta x just to show the variables separately I'll write like this if you continuously write it no problem with that so if I take the the mass of the cone B capital M or a solid cone B capital M what's the mass is going to be capital M is equals to sum of mi capital M is equals to sigma what is mi pi a squared rho over h squared x squared delta x so take the constants outside capital M is equals to pi a squared rho over h squared multiplied by sigma x squared delta x I'm going to apply integration to apply the integration I need more space okay come on මෙතනින් කරන්න I'll do it here you do below that capital M is equals to pi a squared rho over h squared multiplied by integration From where to where puta? Kota inda kotantada? 0 to h, no? 0 to h. 0 to h. This is 0 comma 0 point. This is h comma 0 point. X goes from 0 to h. Then 0 to h. X squared dx. Eka identify karagana belum window. So this one will give you, I don't have enough space to write below this one, so I'll write it here. Capital M is equals to pi a squared rho over h squared multiplied by x to the power 3 divided by 3, 0 to h. 0 to h. Okay. So this gives you capital M pi a squared rho over h squared multiplied by, I will take the 103 outside, we get h cube minus 0 cube is 0, 0. Harane. Okay. So simplify this one. I'll simplify and directly write it. Capital M is equals to, I'll take the 103 here, 103 pi a squared, h cube minus 0 is h cube, h square and h cube simplified h rho. What's the volume of a cone, Puta? O levels. Volume of a cone with the base radius r and height h is 103 pi r squared h. No? If you multiply the volume with the density, you'll get the mass. 103 pi r squared. In this case, instead of r, I have taken a as the radius. A squared h rho. Right? So rho is the density. So when the volume multiplied by the density, it gives you the mass. Or if it is an area multiplied by the density gives you the mass. What density? In that case, we will get the, what kind of a density? Area density, okay? Density of a unit area. This is how we calculate the general mass. This is the general mass. And then using that, this is how we calculate the total mass. Understood. Clear with that. Understood. Clear with that. I need individual responses. Quickly. So practice this one at home, because you will usually forget these things. Make ikmanta amataka wenawa, and you will get confused also. So practice this at home. Okay. So now it's 11. Take a 20 minutes break. I will give you another break. Afternoon break 10 minutes break. So now take a 20 minutes break and come. Will 11:20 I will resume the session. Take your breakfast and come. Mamat khal and na. Take a 20 minutes break. Right. Is everyone there? Quickly drop a message in the chat box. Is everyone there? Yes, no. Okay. Write the topic. Obtaining the general mass of a hollow right cone. Hollow right cone. Obtaining the general mass of a hollow right cone. Quickly draw this. Quickly draw this. Quickly draw this. But remember, this is a hollow cone. Maybe this is how we cut. And until this point, no problem. The height case. The height only the case happens, because when it comes to the height, previously they have a matter, so no issues with taking the height as delta x. Matter fill matter is filled. Now the thing is, matter is not filled, it's a hollow cone. So taking this delta x height here as it is wrong. It leads us to a greater issues. So ehinda calculating the height, to do that I have to take this part separately. Zoom karla. I had to take that part separately and zoom it in like this. So this is a hollow cone. I'll draw like this. Okay. So I'll take this angle as, if I take this angle as theta, this angle is also same theta, make up theta. Okay. So this perpendicular distance is delta x. Okay. So now the radius is not going to change. Make a you guys do. You guys can do this with me. Listen. When it comes to solid hemispheres, the very first one we discussed, we sliced it and make a scene. When it comes to this height calculation or radius calculation, when it comes to hollow matters, the scene goes with an angle. Okay. In hollow hemisphere, the arc length went with an angle. Also, the radius we calculated in terms of sine ratios or as some trigonometric ratios. The method this is delta x. This is adjacent side. Okay, this is hypotenuse. I actually need the hypotenuse, no? I actually need the hypotenuse. Now, hypotenuse is the so cos theta is equals to delta x divided by the hypotenuse. Then hypotenuse is equals to what? Delta x divided by cos theta, which means delta x sec theta. This is delta x sec theta. This is a tiny inclination. So this is slightly inclined. So we ignore the we ignore that one and we take it as a straight height, delta x sec theta. The radius calculation is same. The radius calculation is same because it's a cone. No, radius calculation is going to be the same. Right. Now, when I cut and open this, what do we get, Puta? We get a stripe like this, no? Strip we get a strip like this. This is delta x sec theta. The circumference of the base or the top or a circumference of this one gives you the length. How to calculate the circumference? 2 pi, the radius. What's the radius? Ax over h. Ax over h. So the density is rho. What's this density? Mass per unit area. Mass per unit area, okay, because we calculate an area. How to calculate mi? Area multiplied by the mass per unit area, which is the density. Mi multiplied by length into breadth, 2 pi ax over h multiplied by delta x sec theta multiplied by rho. Okay, multiplied by rho. So this gives you mi is equals to 2 pi a rho over h. Okay, x sec theta delta x. X sec theta delta x. Hari, x sec theta delta x. Then balanna metana puta, what is the variable, what is the constant? Then people think that 2 pi a rho over h sec theta x delta x. X is the variable, no, because that's the length that we are changing. But theta is a fixed angle, no, because that's the half vertical angle. That's the half vertical angle. It's a fixed angle. Who fixed? Sec theta is a constant. This is a constant in this case. Method variable like x only. Theta is a constant. Half angle is not going to change for the cone. Half vertical angle is going to be the same for the entire cone. It's not going to change, right? So what do we get? 2 pi a rho over h sec theta x delta x. This is the general mass. Now we are going to calculate the mass. Let the mass of hollow cone be capital M. Capital M is equals to sigma mi. Capital M is equals to what? How to calculate the sigma mi? Sigma this one 2 pi a rho over h times sec theta x delta x. Take the constants outside, so you get m is equals to 2 pi a rho sec theta divided by h multiplied by integration x delta x. Integration is sigma x delta x. Now I'm going to apply the integration. You can write below that one. I don't have enough space there. So capital M is equals to දැන් ඔයාලට මේක නම් සරල සාමාන්‍ය දෙයක් වෙන්න ඕන. Okay. මුල් ටික විතරයි we have to go it slower. ඊට පස්සේ ඉතින් scene එක තේරෙනවනේ බා. ලොකු scene නෑ. Times integral. From where to where? 0 to h. 0 to h x dx. Sorry, how to do the calculations now? Capital M is equals to 2 pi a rho over h sec theta. X, if you integrate it, you get x squared over 2, 0 to h. Capital M, this is equals to 2 pi a rho sec theta over h multiplied by half. What is x squared then? H square minus 0 squared is 0. So this gives you capital M is equals to this 2 and this 2 cancelling out. H and one of the h is cancelling out. H square minus 0 is h no. H squared no. Cancel vela. Pi a h rho sec theta. Pi a h rho sec theta. If you know the radius of the cone, if you know the height of the cone and the density and the half angle, එතකොට මුගේ mass එක calculate කරන්න පුළුවන්. So integration එක හරියට do the integration. Actually, in this lesson, integration is not that complicated. Okay, the integration that we use in this lesson is very simple integrations. X square usually x to the power n is the most common integration we find in this one, center of gravity. Right, quickly finish it. Quickly finish it. Clear with that? Fine. Understood? Therunada? I need individual responses. Understood. Message done. If you have any unclear part, please do ask me now itself before I move to the next part, next discussion. Tonight we have the pure maths class. Okay, එක තියෙනවා. right? Okay. The pass say, wait, I'll refill the marker and get back to you. Okay, write the topic. Write the topic. Write the topic. Finding the general mass of a finding the general mass of a finding the general mass of a flat lamina. අර ඕලෙල් වල කතා කරන්න පුතා ලැමිනා කියලා එකක් like a තහඩුවක් වගේ එකක් ආස්තරයක් ප්ලේට් එකක් වගේ එකක් flat something. Okay, right. Flat lamina, calculating the general mass of a flat lamina in the shape of a semicircle, the shape of a semicircle, the shape of a semicircle, right? කරන්නකො බලන්න හිතලා කරන්න. That's not a solid, it's not a hemisphere or anything, it's a flat disk. CD එකක් අරගෙන CD එක මේ හරි මැදින් කැපුවා මෙන්නේ semicircular flat disk එකක්. Okay, CD disk, if you divide it into two equal parts, one portion and ඒ වගේ එකක් තියෙන්නේ. So it's a solid, it's not hollow, it's not a wire එකක් නෙමෙයි, it's a flat එකක් තියෙන්නේ, right? It's a disk, half disk එකක් වගේ එකක්, right? You guys give a try, will you? Where try එකක් then? You guys finish it. I'll give you 5 minutes and then I'll do. right? What is it? Obtaining the general mass of a flat lamina in the shape of a semi circle, right? Can you if I take a CD like this, so let's say this is a disc or as a CD, right? So if I divide that into two equal parts, something like this, no? Right? So I'm going to take the center as capital O. What's the idea? This is a disc. CD එකක් අරගෙන දෙකට කැපුවා වගේ. So if you try to slice in vertically slice කරොත් what do we get? We get a cross section, looks same, but what's the purpose of that cross section? ඒක මොකක්ද? It's not a rectangle, it's not a parallelogram anymore. ඒ වගේ එකක් නෙවෙයි. It's just a thin line you are going to get. So keeping that, we can't do any calculations or any discussion, right? ඉතින් මොකද්ද කරන්න ඕන? ඔන්න thinking. So what I'm going to do is I will place this one first of all in a xy axis. Okay. Y axis through the center and x axis through the axis of symmetry. So obviously it's also going to go through the center. Through the center. Okay. Like this. මේක කපන්නේ පුතා. Okay. This is like හිතන්නකො මෙහෙම ගෙදරට මාරි බිස්කට් ගේනවා. Right? මල්ලිකාරයා හරි නංගිකාරයා හරි ඔක්කොම කාලා. එකක් ඉතුරුයි. Right? So you are going to divide the Mari biscuit into two equal parts. Divided. You get a half of a Mari biscuit. The Mari biscuit take a kaha indiddi, right? Manga will again the mocha chuti caliber takapa. Monkey no yalada. So when you are trying to eat the Mari biscuit, divide that into small pieces. Right? Now if you divide them in small pieces according to your wish, right? Squid Games will right? You have to divide them into small pieces such way that you get parts which has similar cross sections. What way I have to divide this? Do I have to split vertically or do I have to split horizontally or what else? What we can do having a similar cross section. What's your idea? Anyone? බලමු හිතන්න පුළුවන් එකෙක් ඉන්නවද කියලා. What kind of a cross section we will get? Anyone? Anyone? One person is saying divide horizontally. One person is saying triangle something. By cutting circle from the center to the circle from center to hemisphere. You have the idea but it's not clear, but okay. Right. Basically මොකද්ද කරන්නේ? මේක කැපුණා කරන්නේ. I think this is what Amra is trying to explain. ඔහොම කෑලි කරලා ගන්න. ආසාවකටත් බිස්කට් එකක් බෙදලා නැහැ. Is this the one you are trying to tell, Amra? Right? තව පොඩි කරමු. More small pieces. සමහර විට sometimes as වලට පොඩ්ඩක් අමාරු ඇති මේක බලන්න. Sometimes eyes වලට පොඩ්ඩක් case ඇති. shape එක බලන්න. So I'm dividing like this. අවුලක් නැහැනේ. I get small sectors which having a similar cross sections. Which having a similar cross sections. අම්බේ ඇතියන්ත එකෙක් ඉන්නවා හිතන්න පුළුවන්. Right? Similar cross sections. දැන් ඉස්කෝලේ කියලා දුන්නත් දන්නේ ඒක වෙන වතාවක්. හරි. අලුතෙන්ම හිතන්න පුළුවන් එකෙක්ට හිතලා තිබුණා no problem. නියමයි. වරු. දැන් වැඩේ කියන්නේ if I'm dividing like this, do I have to measure from the center as a length or do I have to measure as an angle to cut this? To get such pieces, do I have to measure as length or x delta x වගේ length වලින් කපන්න ඕනද? Or do I have to measure theta delta theta වගේ angles වලින් කපන්න ඕනද? How do I have to cut? Now answer that too. That's an easy question. How do I have to cut? By angles or by lengths? How do I have to cut? If I want to cut like this, how do I have to cut? By angles or by lengths? Answer. By angles, no? By angles. Right? So then I have to cut like this, ne? Right? Mama kapanawa, I'm cutting theta here. I measure theta angle and cut like this. Listen now. At a theta angle, I cut like this. Okay? Theta. Another delta theta angle, I cut like this. We get a piece like this. I don't know how piece, right? So we'll separately take that one. Let's take the radius of this one as A, okay? Right. I'll take the radius as A. So we get something like this, no? Or no? Right. This angle is delta theta. Radius is A. Again, the radius is A. Then වැඩේ කියන්නේ පුතා. Listen. You know that Earth. Well, Earth කියලා දෙයක් තියෙනවා කියලා දන්නවනේ. පෘථිවිය කියලා එකක්. Right? අර නිල් පාට බෝලයක්. So there's Earth, no? And you know that Earth is defined as a sphere. Earth is defined as a sphere. You know that it's a bowl-shaped one, no? So which means it doesn't have straight edges. It's have curved edges. Have you ever observed when we are walking, you're walking through a curved edge experience karla tiyinawada? Not about the mountains, I'm not talking about the hills and all. So if you take the Earth, basically, even if you take the entire Sri Lanka, flattening, we feel a horizontal surface, isn't it? But we feel a horizontal surface. Why is that? The Earth is very big. if you from the center, if you divide that into small pieces like this, or kapuhama, very small pieces compared to a small piece can contain multiple countries. Earth එක ලොකුයිනේ. Right? If you take such a small piece, පුතා, if you zoom it in, right, ඔයාට පෙනේ මෙන්න මේක looks like a straight line segment. Actually, circle is a closed plane figure, kind of. It's not a definition actually, and a person can think like a circle is a closed plane figure consisting of infinitely many very tiny straight line segments. Chuti straight line segments. So here, remember this delta theta කියලා කියන්නේ මේ චූටි angle එකක් නෙවෙයි. චූටි angle එකක්. This is a very small angle. පට්ට පොඩි. Very small angle. So to draw for the calculation purposes and to illustration purposes, we write like this. That doesn't mean move මෙහෙම පේන්නේ නැහැ අපිට. If you want to see that, then you will have to zoom it in like 2000 times. එහෙම හිතන්න. පට්ට පොඩි. So this curve actually looks like a straight line segment. More straight line segment එකක් වගේ පේන්නේ. This actually looks like a straight line segment. Hari? It looks like a straight line segment. This is a curve actually, but looks like a straight line segment. ඔය පේන්නේ සරල එකක් වගේ, straight line එකක් වගේ. Okay, so before we come to that part, what could be the length of this one? Arc length, no, A delta theta. We did a similar calculation. I showed you how this A delta theta is coming, no? Theta over 316 to 2 pi r formula only. Angle at the center divided by 360 is in radians 2 pi multiplied by 2 pi radius. Radius is A delta theta, right? So we substitute theta, we are measuring angle, we are measuring in radians. So this actually looks like a straight line segment. This looks like a straight line segment. This looks like a straight line segment. This is a what? These are radii. This looks like an isosceles triangle. This looks like an isosceles triangle. Isosceles triangle. This looks like an isosceles triangle. This is a flat. Then what do we have? We have a what puda? This looks like a straight line segment. Okay. Delta theta is very small. For your betterment of understand right now. Therefore, arc looks like a straight line. Straight line. Mu is an isosceles triangle. If I take the density as rho, what's the density? Density per, mass per square unit. Mass per unit area. Square unit area. Okay, it's mass per unit area. So if I take the general mass as mi, mi is equals to, how do we take the mi? Mi is equals to area into density, no? This is an area into density. How to calculate the area of a triangle? Half into base is A delta theta and perpendicular height. Then perpendicular height ko hand. Find the perpendicular height. Find the perpendicular height. Our perpendicular height එක A හොයන්න දෙයක් තියනවද? This looks like a straight line segment. That doesn't mean so straight line segment එකක් and it's shorter than A, no? And පුතා පිස්සු නටන්න එපා. Think about the concept. We take the complete sector and sector K, this curveness is not visible, but that sector's radius is going to be the same. Make a radius. So the perpendicular height is same as the radius. So since this is looks like a straight line, this curve looks like a straight line actually in practical situation. This is the area, half into base into height, multiplied by the density. So you get mi is equals to half a squared rho delta theta. This is our general mass. Now let the mass of the matter be capital M. Capital M is equals to sigma mi. So capital M is equals to sigma, what is mi? Half a squared rho delta theta. So take half a squared rho is a those are constant. Those are constants. So we get sigma delta theta. I'll write it as 1 times delta theta. Or it's just delta theta, delta theta, sigma delta theta. We get something like this. Apply the integration, identify the proper limit and do it. මොකක්ද දාන්න ඕන limit එක කියලා හිතන්න. So we are cutting. If we take a theta angle and delta theta angle, we get this part of the sector. If I want to cut from downside, then I'll have to measure minus then actually the angle goes from minus pi over 2 to plus pi over 2, no? Minus 90 to plus 90. You know that these are positive angles, these are negative angles. This is minus 90 to plus 90. Minus pi over 2 to plus pi over 2. Previously 0 to pi over 2 because we take theta, we cut like this, vertically capuit. So this part also coming if you measure the angle, one positive side measure because we are cutting vertically, no? Now we are not cutting vertically, we are cutting in a different way. So we have to cover up the entire disc, then I'll have to go from minus 90 to plus 90. So then we get m is equals to half a squared rho integration minus pi over 2 to plus pi over 2. Nothing delta theta means 1 d theta, right? So m half a squared rho multiplied by 1 integrate with respect to the subject theta is theta, goes from minus pi over 2 to plus pi over 2. Upper limit minus the lower limit. M half a squared rho, we get pi over 2 minus lower limit minus pi over 2. Right? So we get capital M, this is equals to half a squared rho multiplied by minus into minus plus pi minus into minus equals to plus. This one is 2 pi over 2, you know, which is pi. So which gives you the mass. Capital M is equals to half pi a squared rho. Half pi a squared rho. That's the mass. On the scene. Okay. Obtain the general mass of the shape of a semicircle. Right. This is how we get concepts. Draw this, finish this, and then write the subtopic. Obtaining the general mass of a thin wire in the shape bent in a shape of a semicircle. Do it. Right. Done. Then making Pasiliana subtopic. Right, the subtopic. Obtaining the general mass of a general mass of a wire. Obtain the general mass of a wire bent in a shape of a semicircle. Bent in a shape of a semicircle. ඔයාලා අහන්න පුළුවන් මගේ මෙහෙම ප්‍රශ්නයක්. අනේ සර් වයර් එකක් සෙමි සර්කල් විදිහට නැව්වත් මොකෝ නැවුව නැතත් මොකෝ උගේ weight එක mass එක කොහොමද change වෙන්නේ? Right? You should come across that question, I think. කම්බි කෑල්ලක් අරගෙන let's say 100 grams of weight, 100 grams thin wire. You are bending it like a circle or a semicircle or as a square. Does it going to change its mass? No. It's not going to change the mass. Then why we are discussing this? Because depending on the shape of the wire, center of gravity changes. Center of mass changes. Hare, can a mass change in center of mass and center of gravity changes? Right? Can obtaining the general mass of a wire bend in a bend D the T then nikila man danne apda bend in a shape of a semicircle. Now let's say you have a wire like this, kambiyak, okay, a metal wire like this, and if you keep this metal wire like this, let's say it's a uniform metal wire, so the density is same in every point, so the center of gravity is in exactly in the middle. Center of mass and the center of gravity both are in the exactly in the middle. But when I am bending that one, or as when I'm changing its shape, then මම ඌව මෙහෙම නවනවා වයර් එක. ඔහොම දිග වයර් එක මෙතනින් නවලා. ඔහොම නවනවා. This one's center of mass is or center of gravity is not here. මැද නෙවෙයි තියෙන්නේ. It's in between this space. මේ space එකේ ඔය හරිය තමයි තියෙන්නේ. But the line of action goes through the symmetric axis. Line of action goes through the symmetric axis of symmetry. Okay? Line of action goes through the symmetric axis. Right? දැන් මේවා අලුත් දේවල් නෙමෙයි physics වල උගන්වන දේවල්. හරි? Studied those things in physics, right? Yes. No. Center of mass, center of gravity සෑහෙන කාලයකට කලින් කරලා ඇතිනේ. Yes, no. Yes or no. වරක් දන්නේ ඕවා හරි MCQs වල physics පොඩි දේවල්. However, we have a thin wire, okay, thin wire bent in a shape of a semicircle. මෙන්න මෙහෙම. Right? So draw dotted lines because this is a thin wire. There is no matter here. Okay, there is no matter here. But still, so let's take the center as capital O. I'm going to keep this on a XY coordinates plane like this. This is the last one that I'm discussing in detail. හරි ඊට පස්සේ ඉතින් තනියෙන් කරන්න දෙනවා සෙට් එකක්. Why? X. Okay. Now I'm going to cut this one such way that it's having a similar cross section, but this thing is a wire cross section කියලා scene එකක් නැහැ. But then I'll have to take similar shape. Similar shape. Then again, like in the previous, you had to cut like this. No, this is how I had to cut. So the parts that we divide and taking is just a small piece of wire. Kambi kallak inni, not a sector. Not a sector. We get a small piece of wire. Ne? We get a small piece of wire. Then what we do? ඇත්තටම මෙහෙම අඳිනවට වඩා ලේසි. I think this one gives a idea like we are cutting into sectors වගේනේ පේන්නේ. So it gives you a misunderstanding. So I will draw like this. මම මෙහෙම අඳින්නම්කෝ. ink ටික අපරාධ කමන්නේ. Right, I'll draw like this. Right, origin. You see? So if I draw like that, then you might think again, no, I'm going to cut that into small, tiny pieces like this. This is a wire, small, tiny pieces like this. Draw with me, yeah? Draw with me. Draw with me. Oh no. Okay. Right. To the horizontal, at a theta, again you can see that we have to measure angles, no? So let's say I measure theta angle and cut, and again a delta theta angle and cut. So I get a piece like this. Okay, so if I take that outside, so I get with the center capital O, y dotted lines, no matter, I get a piece like this, right? So let's take the radius as A. I'm taking the radius as A, right? Radius as A. Hurry. So what is this? This is going to be A delta theta. That's going to be A delta theta. What else it has? Nothing puta. එහෙනම් මුගේ density එක ගන්න කොහොමද? Let's say density is equals to rho. What is this density? Mass per unit length. Practically all three density types we get, no? අපිට එක density එකක් හම්බ වෙනවා volume. That's for solids, right? And then flat surfaces with the density related to the area. Now this one is density in terms of a length. For 1 centimeter, what's the weight? Sorry, what's the mass? Density means in unit area, in a unit component, what is the mass that you have, no? Right? Unit length. Now this one, if the density is 10 grams per centimeter, means if you take a 1 centimeter length, you will get a 10 grams of mass. That's the meaning. So it doesn't have anything else, no? It just have this A delta theta length, right? A delta theta length. Mi is going to be right? A delta theta multiplied by density. It's going to give you the mass. If let the mass of the matter be capital M, total mass be capital M, then capital M is equals to sigma mi. Then capital M is equals to sigma A delta theta rho, or is A rho delta theta. A rho delta theta. This is a general mass. Make this is what we wrote as the topic. Obtain the general mass, but we can do a further calculation using that. Right. Now this is going to be capital M is equals to sigma a take A rho outside sigma delta theta. So capital M is equals to A rho integration. Again, we have to divide from bottom top part, both we have to, then minus pi over 2 to plus pi over 2. What is this? 1 d theta. Again, capital M is equals to A rho 1. If you differentiate with respect to the integrate different with respect to theta, it's going to be theta. It's going to be minus pi over 2 to plus pi over 2. So this gives you capital M A rho pi over 2 minus pi over 2. So this gives me like something like this. Capital M is equals to minus into minus plus 2 pi over 2, which is pi. So we get pi A rho. Pi A rho. Okay. Right. Finish it. Finish it till ඊට පස්සේ now ඔයාලගේ වැඩ පටන් ගන්න වෙලාව. දැන් ඔයාලගේ වැඩ පටන් ගන්න වෙලාව. Right. මගේ වැඩ ඉවරයි. My works are done. Done. If you all have completed, draw message in chat box. Yes, the no, the done. 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 Completed. Quickly. Completed. Finished. This one is going to be delta theta. Okay, write the question. Write the question. Write the question. Write the question. Find. Write the question like this. If the mass of the following matter, if the mass of the following solid matter, write the first question. If the mass of the following solid matter, this one is actually a theory. I am giving a theory discussion. We'll do like questions. First question. find the mass of the following solid matter. If the mass of the following solid matter, if the mass of following solid matter is capital M, put a comma, find capital M. If the mass of the following solid matter, okay. If it is a hollow, I will mention as hollow. Now this is a solid. And if they haven't mentioned anything in specific, hollow the solid the kila nattang, most of the time it's solid. With the practical content or as context, you have to decide whether it's going to be a solid one or a hollow one. Usually hollow nang denawa, ehema dunne natta most of the time it's solid. Sometimes there might be a tricky situation where practically gattahama oka hollow window on ekak, they will not mention as hollow. They think that student can understand this one as hollow kila hitai. So you have to be very careful. Now in this case, since you are still training, I will take it as solid. Solid killer ganna. Okay. Right. Here see. If the mass of the following solid matter is capital M, find M. Basically M araganna giyanne. Okay. Don't draw. First of all, listen. From a listen how this figure is made, how this solid has been created කියන එක හිතන්න බලන්න. From a solid sphere, okay, from a solid sphere of radius simple A, okay, of radius simple A, radius එක simple A, from the center at A over 2 distance, at A over 2 distance, which means half of the radius distance, move kapala. Move kapala. So this part has been cut and removed. Move kapala dala. This one is cut and removed. So this part is not there. And then they have cut this one again at a 5A or as 5 over 6A distance. මෙතනිනුත් ආය කපලා. මෙතනිනුත් ආය කපලා. මේක ඔයාලගේ සිලබස් එකේ තියෙන ඒවා examples විදිහට. Right. This is the solid we have. This is the solid we have. Now I am asking you to calculate the mass of this solid. මෙන්න මුගේ mass එක හොයන්න ඕන. So basically, no, this part is not there, this part is not there. මෙන්න මේ area which is not highlighted, that's the part there. This is actually the shaded කියලා කියන්නේ අයින් කරපු කෑල්ල. Unshaded part is the part that is remaining. So that's a solid. That's a solid. Okay. It is not hollow. It's a solid matter. So you have to calculate the mass of that. ඉවර කරලා. Try that. You guys try it. මොකක්ද හිතන්න ඕන? What do you have to think? How to cut? How to cut? ඒක හිතන්න ඉස්සෙල්ලා. When you decide how to cut, and based on that only you can make the other calculations. Then how to cut කියන එක කොහොමද හිතන්නේ? How to think, how to cut? We have to cut such way that the small pieces you get having a similar cross section. එක වගේ cross section එකක්, similar cross, not equal cross sections. Circles නම් දිගටම circles තියෙන්න ඕනේ හැම එකාගෙම. Such way that the cross section has similar cross sections. එහෙමයි හිතන්නේ. First thing, how to cut. How to cut කියන එක කොහොමද හිතන්නේ? How to cut, how to think, how to cut. Okay. Once you cut, each small piece that you get should have a similar cross section. එකම shape එකේ. Okay, same shape cross section එකක් තියෙන්න ඕන. Right? Such way you have to think and do. කරන්න බලන්න. Give it a try. ඔය බලන්න මගේ බුද්ධිමත් ළමයි ටික ඔලුව චුට්ටක් කල්පනා කරන්න ලොකු සීන් එකක් නෑ ඕකේනේ. So I have given time to think since this is the first thing you are doing on your own. Sometimes you might have done some errors. Right. Now, so the compound figure, actually this is not a compound figure. Yeah, compound figure එකක් කියලා කිව්වොත් no problem. So this one kind of an object like this, no? So then if I'm not going to draw this again. You have to draw again. Okay, better if you can draw again. මෙහෙම තියෙනවා. I'm keeping the center. I'm going to keep the y-axis through the center of the initial sphere. Through the center of the initial sphere. කලින් හිටපු එකාගේ center එකකින් යවනවා. Like this. So what happens if I draw the x-axis like this? If I draw the x-axis like this, if I draw the x-axis like this, this is our new, this is the solid and this part has been removed. This part has been removed. මේකත් අයින් කරලා. This is the solid we have. No, this is the solid we have. This is, if I'm keeping on a xy coordinates plane, what is this? This is minus, no, the length is 5 over 6. You see, length is 5 over 6a, but the coordinate is minus 5 over 6a comma 0. What is this? Plus a over 2 comma 0. Right? Now, how to cut? This is a solid. So slicing like this is okay, you know, because each slice is going to give you a circular cross section. A circular cross section. Right? A circular cross section. So what I'm going to do is, we know this length is AO2, no? Okay, we know the distances. We know the distances, so for the moment I'll keep like this. That's why I asked you to draw separate. Yeah, for me, if I draw again, it takes time. That's why I didn't draw again. You separately draw this one. Question again separately draw this one and do like this. Right? Now, I'm going to cut at x swelling kapala like this. I'm going to cut at a x distance from the center like this, and a delta x distance from the center. Our delta x duty distance, yeah, delta x distance from the center, like this. Okay. So this is the solid we have, and this is the radius. Radius, I gave it to you as a, no? I told you the radius as a. Take the radius as a. Right? So if I take this solid separately, the piece separately that we have cut, what do we have? We have a solid like this with a small curved surface, and like this. This is x, this is a, means the radius is what? A squared minus x squared square root of it. Since this one is considered as a cylinder, height is going to be same delta x. Okay. If I take the density as rho, okay, I didn't give you that data. Take the density as rho. Mama data you take it as rho. Usually in questions they will give you the density as rho. Okay. So now I'm going to calculate the, if I take this one, we first of all always remember we have to calculate the mi, or else the general mass. General mass again, the main mass we can calculate using integration. Mi is equals to, how to calculate the volume of a cylinder? Volume into the density. What is how to calculate the volume of a cylinder? Pi radius square times height multiplied by the density rho, right? Rho. So this gives you mi pi rho a squared minus x squared delta x. We need to calculate m. How to calculate m? Sigma mi. What is sigma mi? Sigma pi rho a squared minus x squared delta x. Then capital M is equals to, take the constants outside, pi rho sigma a squared minus x squared delta x. So capital M is equals to pi rho integration. Then tama part එක තියෙන්නේ. X we are cutting from the negative side to this side, no? Minus 5 over 6a2 plus a over 2. Lower limit is here, plus 5a over 6 2 plus a over 2, a squared minus x squared dx. And ඔය part එක තමයි විශේෂ. How to take the limit in the integration. To decide that one, you have to place the given compound figure in a proper xy, in the xy coordinates, appropriately place it. ගන්න ලේසි විදිහට තියන්න. එතකොට වැඩේ ලේසි. If someone asks me, sir, can't we keep this xy y axis and x axis on this side and do? කරන්න පුළුවන්. හැබැයි simplification සමාරුයි. This one is easy. So always remember, when we get something like this, it's better to place in a situation like this. If it is a hemisphere වගේ එකක් නම්, placing on the positive side is easy, right? So it's your decision, right? I'll take like this, capital M is equals to pi rho. I'm going to give the integration separately. Integration minus 5 over 6a2 plus a over 2 a squared dx minus integration minus 5a over 6 2 plus a over 2 x squared dx. So capital M is equals to pi rho, right? Take a squared outside, a square outside, integration minus 5a over 6 to a over 2 1 dx. So I'm not going to write like this directly, we'll do the integration. A squared is a constant, taking it outside, 1 dx, x differentiate integration is x, one integration is x, minus 5a over 6 2 plus a over 2 minus x cube divided by 3 minus 5a over 6 2 a over 2. Capital M is equals to pi rho. Hurry. We get a square multiplied by, inside the brackets, upper limit minus the lower limit, a over 2 minus 5 over 6 a, or is 5a over 6. Subtract the lower limit. Lower limit is minus 5a over 6. Some students, when they put this minus, they forget about this minus to write. එහෙම කරන්න එපා. Minus 1 over 3. A over 2 cube means a cube over a over 2 cube means a cube over 8. Minus 5a over 6 cube means 5 cube is 125 minus 125 a cube divided by 6 cube is 6 times 6 36, 36 times 6 is equals to 216 නේද? 36 times 3 is 108, 216, yeah, 216. ඔහොම එකක් එන්නේ, right? So here minus 5a over 6 නේ දාන්නේ. So minus 5 over 6, we get something like this. So we get capital M is equals to pi rho. Simplify this one. Minus into minus plus whenever. Let's quickly do the simplification here. See, no need to write all the steps. Minus into minus plus a over 2, 5a over 6. So this is going to be 3a over 6 plus 5a over 6, 8a over 6. 8a over 6 multiplied by a squared is 8a cube over 6 minus 1 over 3. Inside the bracket, this one also I can simplify and directly get it. No, here see, 216 take a common denominator, minus into minus plus whenever. 216 take a common denominator. Do we can we simplify 216 in terms of 8? No. Dekama 4 multiples. Yeah, both of them are multiples of 4. So this is 4 times 2, this is 4 times 54, no? 54. 4 times 2, this is 4 times 2, this is 4 times 54 kilogianne. This one 4 times 54 vendanam and multiplied by 26. Neda? More 26 will multiply කරොත් හරි නේද? බලන්න. 8 times 20 26 නේද? 26 8 will multiply කරොත් 160 26 නෙමෙයි, sorry. Make 54, right? Take a common denominator and simplify. This is 4 times 54. This is 4 times 2. So 54 winner. 4 times 2, 54 winner. 27. 27 will multiply. 27. Multiply both numerator and denominator by 27. So 27 a cube divided by 216 plus 125 a cube. Then 125, 27 is 150, 152 a cube. So 103, 152 a cube divided by 216. Oh, my simplifications are wrong. Let me know. Simplifications are then capital M is equals to pi rho 152. We'll take the cube outside, simplify right? I'll take the a cube outside, do the numerical simplifications. 8 over 6 minus 152 over 3 times 216. Right? It's a numerical simplification. Tagala simplify karanna balan. Kiya denne? How much do we get? Simplify kalagan. You guys simplify and take the value. How much is it? It's a numerical simplification, okay? Take common denominator and simplify. So this is 3 times 216. No? Make a 3 times 216. This is 3 times 2. So to more 216 mean 2 multiply karanna 108 right? So then I have to multiply this one, both numerator and denominator, by 108. So this gives you 3 times 216. Make a 3 times 216 winner. So common denominator is going to be capital M pi rho a cube. So 108 times 8 minus 108 times 8 minus 152 divided by 3 times 216 kilo a. Simplify and get the answer. You have to simplify and write the answer. I'm not going to write it. Right? ඔයාලා simplify කරලා answer එක තියන්න. ඊට වඩා easy simplification එකක් තියෙනවා නම් කරාට කමක් නැහැ. Okay? If you keep this edge at this point and take from 0 here, take from 0 to එතකොට ඇවිල්ලා distance එක වෙනස් වෙනවානේ. So if you are keeping the object like this, මෙන්න මෙහෙම නම් තියන්නේ. If you are keeping like this, ඔහොම නම් තියන්නේ, this one is going to be 0 to මෙතන තමයි, here we have the center 0 to the center we have 5a over 6 distance, and this is a over 2. Then integration is going from 0 to what puta? 0 to 5a over 6 plus a over 2. මුන් දෙන්නගේ එකතුව තමයි මෙතනට එන්නේ නේ. because x goes until that point. No? So this is going to be 3a over 6, 8a over 6 වෙනකන් යනවා. It's going to go until 8a over 6. So 0 to 8a over 6 කියලා limit එක දාලා කරත් no problem. But in such case you will have to place it appropriately. Placement එක ඔයාලා ලස්සනට පෙන්වන්න because මේක අඳිනවට ලකුණු දෙනවා. ඒවට ලකුණු දෙනවා. Right. So shall I give you another question? Fine. Any unclear part in this? I need individual responses quickly. All good. I need individual responses. Finish it. Done. Quickly. What's the difference? Taking the general mass is not changing. ඒක ඇවිල්ලා පරණ එකම තමයි. Applying the limit is the important one. So integration also not the problem. Simplification තමයි ළමා වරද්ද ගන්නවා නම් වරද්ද ගන්න. හරි? Simplifications carefully කරන්න. Right. Right, the next question. Right, the next question. Calculate the mass capital M. Calculate the mass capital M of a matter. 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 Made by removing a part from a made by removing a part from a hollow sphere of radius simple a. Hollow sphere of radius simple a. So this is how is it how it is given now. That's the second question. Do this කරන්න. This is a hollow sphere. From this hollow sphere of radius a, from the center at a over 2 distance, at a half of the radius distance, they have cut and removed this part. මෙන්න මේ part එක කපලා අයින් කරලා. Okay, this is the new solid or is new matter, and this is a hollow matter. මේක hollow එකක්, not a solid. This is a hollow solid. This is a hollow one. කරන්න බලන්න. This is a hollow matter. ඝන වස්තුවක් නෙවෙයි, මේක කුහර වස්තුවක්. This is the object given. Take the density as rho. Take the density as rho. No problem. Right. Do it quickly. Okay, right. කොහොමද කරන්නේ දරුවෝ මේක? Right. Again. Hollow hemisphere we discussed no. We notice that මෙහෙම කපන එකේ තේරුමක් නැහැ. Because if we cut like actually sorry this is how we have to cut no, this is how we have to cut, but the measurement is going to be not from lengthwise but angle wise no. Right, I'm going to place like this. Here, see, yeah, I'm going to place like this on the xy coordinates plane, y axis through the origin මෙහෙම. What did I say? First thing you have to think, how am I supposed to cut this such way that having a similar cross section? Then obviously I have to cut like this. Then how do I take the general piece representing all those pieces? Cutting at a theta angle. Okay, at a theta angle put a cut kapana. Again at a delta theta angle I'll take like this. Instead of taking this end, I can't take at this end, I have to take like this. At a theta angle I cut like this. Okay, at a delta theta angle I cut like this. So this is going to be one cut. ඊට පස්සේ මෙතනින් තව cut එකක්. Right, we get something like this. So when I take that one outside, what do we get? අපිට හම් වෙන බලු කරපටියක්. Can you remember? Now this one is if the diameter is a, this is a delta theta. This is a delta theta, no? This is not going to be delta x, it's a delta theta. How about the radius? If the radius of this one is a, how did we got? A sine theta plus delta theta. Delta theta is small, so we took it as a sine theta. Now this density is actually what? What's the density? Density is a density per square unit, no? So mass per square unit. You can name mass per unit area. Right, if I cut this one and open, I get a stripe like this. Neither, you can remember, is a delta theta. What's this length? 2 pi a sine theta, 2 pi r. This one's circumference is the length. So what is mi? Length into breadth, 2 pi a sine theta times a delta theta. That's the area multiplied by the density rho. So mi is equals to 2 pi a squared rho sine theta delta theta. So if I take capital M, I'll write it there, I'll write it here. Capital M is equals to sigma mi. Capital M is equals to sigma 2 pi a squared rho sine theta delta theta. Capital M is equals to 2 pi a squared rho integration. Then tama වැදගත්ම part එක. Tell me, I should measure the angle from what to what? කීයෙන් කීයද? From what to what? Tell me in radians. In radians only we do the calculation. What to what? කවුරු හරි අම්රා තුයිස්ගා ඉන්නව නේද? Anyone? Natasha? Yusuf? Someone? From where to where should I measure the angle? Should get in order to cover up the entire solid or the entire matter? To cover up the entire matter, from what to what do I have to take the angle? කීයෙන් කීයද? Think. From what to what do I have to get the angle? Hitan. Obviously, කොතනින් පටන් ගත්තොත් should finish at pi, no? මෙතෙන් එන්න බෑ. Should finish at pi. Right? Should finish at pi. From where to where කියලා හිතන්න. From where to where කියලා හිතන්න. Finish the question. Finish the question. Finish the question. Somehow we have to finish at pi, no? Pi වලින් ඉවර කරන්න ඕන. Where to start? We have to start from this end. No, මෙතන කෑලි නෑ. We have to start from this end. කියන්නේ මේ end එකට අදාළ angle එක බලන්න ඉතින්. Let's say this is the end we have, right? මෙතන end එක. Here we have the center. This is A over 2. This is A over 2. I need to calculate the starting angle. I'll take it as alpha. What is this? A. So let's take cos alpha. A over 2 divided by A means multiplied by 1 over A, no? Half, which means I have to start with 60 degrees. 60 degrees in Patangarang, you have to finish at 90 degrees, sorry, 180 degrees. Pi over 3 to pi. That's the complicated part in this. ඒක decide කරන එක තමයි අමාරු වැඩි. අමාරු නෑ ඉතින් ඇස් පේනවා නම්. Common sense තියෙනවා නම් from here we have to go from not from 0, no, because 0 ඉඳන් මෙතනට වෙනකම්ම no matter, nothing is there, cut and remove. මෙතනින් තමයි පටන් ගන්න. So if I join these 2 points, so that's the starting angle, no? So plus pi over 3 to pi වෙනකම් යන්න ඕන. Then it will cover the entire object. So m is equals to 2 pi a squared rho sin theta. When you integrate it, you get minus cos theta. This one from pi over 3 to pi. So capital M is equals to 2 pi a squared rho. We get minus cos pi minus cos pi over 3. So this gives you capital M is equals to 2 pi a squared rho. Cos pi is minus 1, minus pi over 3 is half, minus 1 minus half is minus 3 over 2, minus 2 minus plus 3 over 2. So this gives you plus 3 over 2, 2 and 2 cancelling out. So we get 3 pi a squared rho. This is the mass. This is the mass. Right? හිතන්න පුළුවන් වෙන්න ඕන. Right? Right. Okay. එහෙනම් මොනවද කරන්නේ? තව ගානක් දෙන්නද? නැත්නම් පත්‍යාවත් ඉවර කරමුද? තව ගානක් දෙන්නද? Or else shall we finish the class? Someone has joined now. Sometimes if you are learning this for the first time, sometimes you might not understand. Madara. එහෙම නැත්නම් අපේ ළමයෙක්ම තව device එකකින් join වෙලාද ඉන්නේ? ගියා. Right. මගේ උන් ටික කියන්න බලන්න. Throw a message in chat box. Shall I give you another question or shall we finish the class? So the topic is not for this question, na? මේක ඇවිල්ලා මේ question එක නෙවෙයි. මේක this was the previous question. Okay. Hari, අවුලන්නේ. So in center of gravity, ඕන කරන mass calculation parts are done. Now we have to learn about center of gravity. Before that, write this question, homework question එක ලියා ගන්න. There's a from a hollow sphere, from a hollow sphere, මෙතනිනුයි කපලා from මෙහෙම කපන කියන්නේ හිතන්නකො. So from this is the hollow sphere of radius a, hollow, hollow. This is a hollow object. Okay, radius is a, at a over 2 cut and removed. This is a over 2, and again at a over 2 cut and removed, a over 2. Calculate the mass of this one, not the center of the mass, still center of gravity, center of the mass we didn't discuss. Calculate the mass of this one, calculate the mass of this one, take the density as a, so take the density as rho, take the density as rho. Take the density as rho. Okay, so now listen carefully. එතකොට center of gravity කියන පාඩම ලබන සතියේ class එකේ ඉවර වෙනවා. Next week revision class එකේදී it will be done. So as majority of the students here, and when I was asking about this thing, time change of the revision class, these two were not there. We have to discuss only two parts. We have to discuss the calculating the center of gravity of a symmetric object. Next topic is calculating the center of gravity of compound symmetric objects. Okay, compound O, it's a single O, it's going to be symmetric objects only. We are going to discuss in the syllabus. The center of gravity completely will be done in our next revision day. Actually, it's like a theory students and revision students together. So once it is done, then we are going to discuss the simple harmonic motion. Before simple harmonic motion, I think frameworks were doubts like you were, and I think we didn't complete the frameworks past papers also. So I will take the frameworks part again first. On the same day we'll be moving on to simple harmonic motion as well. So this month I'll be discussing simple harmonic motion also in the revision class. So January first week, second week with the center of gravity, simple harmonic motion calculations of away, and then in our usual applied mathematics sessions, relative velocity almost done. Two more parts we have to discuss. Relative velocity done, and then relative acceleration. And then in January, statistics and probability seminar will be happening. So AK stat prob base also will be done. So with that, when it comes to applied mathematics, as a main lesson, we'll have to discuss only the circular motion and impulse and collision. Oya parts the kata karanne vitarai thiyenne in applied maths. So syllabus is almost done for theory students. When it comes to revision class students, we have started with center of gravity, it passes in simple harmonic motion, and then only we'll be discussing about other lessons QA from grade 12 to 13. The complete syllabus will be done again throughout the revision classes. So if any of the theory class students haven't completed their works properly in grade 12 and 13, you can join the revision sessions on Saturdays morning and complete the work. So the revision session moving forward will be happening on Saturday morning probably. Tamat lamai dennik mata confirm karanna thiyena hariyata. Once they confirmed, I will take the class, revision on Saturday morning. Okay, I will inform you all about it. So not this Saturday, from next week Saturday onwards we'll be having the revision. Okay, so then before we wind up the session today, all good understood? I need individual individual responses from each student. So the one who joined late, you can get the recording of today's session. Okay, I will share it in my communities and groups. You can get it from there. All good. Right. What do you think about center of gravity? Still, we didn't discuss the center of gravity. We still discussed how to calculate the mass of an object. Object එක mass එක ගන්න part එක විතරයි we didn't we discussed. We did not discuss the center of gravity. How to calculate the center of gravity? That's just a small part. You just have to calculate, take the moment around the y-axis. That's a very small part. ඒක කතා කරලා compound figures කතා කරාම center of gravity خلاص done ඉවරයි. Okay, and then past paper discussions only we have to do. Right, done. All good. Okay then, good luck guys. Tonight we have our pure mathematics class as usual, no changes in that. Hari, pure mathematics class එක තියෙනවා 7:30 onwards. Today we'll be finishing integration main parts ඔක්කොම ටික ඉවර කරලා theory ඉවර කරලා දානවා, and then if time permits we'll be doing the past papers. Right, so good luck. You all can leave. We'll meet in our evening session. යන්න පුළුවන්.